What does deep mean when it is measured not only in meters but against the long, indifferent arc of time? What is the weight of a place so remote that it feels like the underside of the planet itself, a place where light cannot enter, where pressure is a physical concept with teeth, and where memory is swallowed by cold and crushing gravity? These questions arrive before any description of landscape, because the Mariana Trench is not merely a hole in the ocean, it is an idea, a threshold between what humanity can know and what the Earth keeps to itself. The Mariana Trench cuts into the western Pacific like a seam in a vast, wet cloak. Somewhere within that seam, almost 11,000 meters below sea level, deeper than the height of Mount Everest is tall, lies the Challenger Deep, the trench's lowest whisper. To stand, even figuratively, at the bottom of that vertical ocean is to confront disproportion, the scale of the planet's skin against the lifetime, the thinness of human presence against geological patience. If Everest were placed within the trench, its peak would still be suffocated by thousands of meters of seawater. The math is banal, and yet it humbles. Thousands upon thousands of atmospheres press inward there, a silent, relentless compression that would squeeze a human body flat like a page. It is an environment as alien as any imagined on Mars, and it exists right here, wrapped in the blue home of humanity. The trench's physical facts are stark and simple enough to memorize. Depth on the order of 11 kilometers, temperatures near freezing, a roar of tectonic plates meeting and one slipping under another, carrying sediments and whatever lies upon them into the planet's maw. But the lived reality, the sensation, if a human heart could properly feel it at those depths, is made of subtler materials. It is an absence of color beyond bioluminescent points, a pressure that is not merely pressure, but a statement of exclusion, a cold that preserves and preserves and preserves and preserves. For the voyaging mind, the trench is both a place and a question. What can survive in a darkness where the sun's photons never penetrate? What stories might be written in mud that is never turned over? What has already been erased? Only a handful of times has the human body been borne to those depths in a pressurized vessel, and each descent has been less an arrival than a translation, a conversion of the visible into telemetry, of sensation into data. The world below does not look for observers, it continues in its own tempo. Instruments creak, dashboards bulge under the weight of 1,000 atmospheres, and the light of a submersible's lamps pushes into blackness like a timid intrusion. Sediment, so fine it moves like air in those conditions, rises in slow, deliberate plumes when touched, and the seafloor responds to contact as if to a foreign language. Cameras illuminate a landscape of soft terraces and daunting drop-offs, a place of subtle geomorphology carved by currents and the grinding teeth of plates. There is a human drama here, but it is a drama of smallness and persistence rather than conquest. The engineers who design deep-sea vehicles spend years negotiating with material limits. Hulls that resist half a dozen nuclear pressures, systems that must work malefic-free for long hours, and life support that can simulate a slice of the surface within a tiny sphere. Those technical rehearsals are themselves stories of faith. Faith that metal and composite can be trusted to hold back a world's worth of pressure. Faith that cords of fiber optics can carry back images that no eye can see directly. Yet even when a camera returns footage of a slight of bioluminescent life, the images read like relics from another planet. Creatures in the Hadal Zone, the deepest ocean domain, are often pale or transparent, adapted to a regime of scarcity and darkness. Their shapes are shaped by the economy of survival, slow metabolisms, opportunistic feeding, a reliance on nutrients that drift down from sunlit waters above or bloom from the mineral breath of the earth itself. The trench's geology tells a broader, deeper story. It is a place where tectonic memory is kept in layers and where Earth's own processes of forgetting and renewal play out with majestic indifference. The Mariana is a subduction zone. The Pacific plate dives beneath another, carrying with it whatever clings to its oceanic crust. That sinking acts like a slow planetary eraser. Any object on the seafloor might be trapped, pushed into heat and pressure, folded into the mantle stew over tens of millions of years. In human terms, these are timescales that collapse the bravest narratives of permanence. Stone monuments that might seem eternal decay under such regimes. Wooden artifacts rot and are consumed. Even metal corrodes in. The long, salt-saturated patience of ocean chemistry. The trench is therefore not merely a repository of odd life, it is a workshop where Earth remakes its surface in cycles that dwarf civilizations. That thought opens a strange tunnel of speculation. It invites the mind to consider vanished things, not the romantic, cinematic ruins of a lost Atlantean metropolis with domes and roads, but the quieter possibility that entire chapters of the planet's habitation could be erased with very little trace. If human societies once rose and fell before the aid of recorded history, their wide language marks might be hidden or destroyed by subduction, by sedimentation, by chemical dissolution. Time in the trench is not linear memory, but a sedimentary library in which many entries are shredded. Yet even as the planet erases, it bequeaths hints, anomalies in chemical signatures, unusual isotopes, traces in sediment layers, the kind of evidence that invites careful listening. Listening is the right metaphor for exploration here. Light is useless beyond a few hundred meters. Instead, the deep ocean speaks through sound, through chemistry, through the textures of mud and the slow accumulation of carcasses from above. Particle flux, the steady rain of dead matter, becomes the food for deep communities. Chemical gradients become places of life, like the ephemeral oases around hydrothermal vents in other parts of the seafloor. The trance of the trench is one of small, intermittent gifts. When a whale dies on the surface and sinks, it becomes a banquet for a suite of organisms that will subsist on that nutrient bonanza for years. The deep is not infertile, it is disciplined. Its resources arrive rarely and are consumed slowly. There is terror here, but it is a measured terror, the kind felt when a person contemplates their own impermanence against geologic durations. Deep time puts human accomplishments into a new scale. The engineering of a city, the carving of stone, the forging of a metal, these are acts of urgency and beauty, but they pale when the planet's conveyor belt begins to grind. The trenches of the world, then, are a reminder not only of Earth's power to destroy, but its equal power to absorb and incorporate. The planet collects and reprocesses our detritus, turning artifacts into minerals, narratives into isotopes, stories into layers. Yet this erasure is not total. The planet is a selective archivist. Some things persist in unexpected ways. Glass, ceramics, and certain stone constructions resist chemical dissolution surprisingly well. Under the right circumstances, sealed in anoxic mud, isolated from the grinding forces of subduction, these objects can survive for tens of thousands of years, even hundreds of thousands. The deep ocean can thus preserve records like a deep freeze. Microbial mats can entomb objects, layers of silt can seal away surfaces, cold can inhibit decay. A shard of pottery may be tumbled into the Hadal, and, if it is not dragged down a tectonic throat, may lie intact under the slow, indifferent rain of particles. The mind must hold both images at once, the eraser and the archivist, the destruction and the preservation. This duality cultivates the primary tension of the Mariana story. On the one hand, there is the sublime and almost spiritual scale of geological processes that obliterate evidence. On the other, there are these slender windows where something endures, a sliver of human past preserved in mud like a message in a bottle. For those who parse the planet's long memory, every core sample returned from the Hadal is a possibility. Each dust deposit, each layer of shell, each trace of organic carbon is a page in a book written in a hand that took its time. Analyzing those pages is painstaking. Sediment cores are sliced in controlled rooms, their thin lamina scanned for chemical ratios, for microfossils, for pollen and charcoal. Radiocarbon and other dating methods become translators. They place impulses in a timeline. Sometimes the results arrive as a slow revelation, a spike in metal concentration that suggests human metallurgy, a sudden influx of charcoal that hints at distant fires, a pollen signature that speaks of terrestrial landscapes altered by human hand. None of these is proof of a grand lost civilization, but together they accumulate into a vocabulary of possibility, and the Mariana Trench sits as a punctuation mark in that vocabulary. It is a place that challenges the very audacity of human permanence. The trench is not an antagonist in a narrative, it is a teacher. It instructs in humility by showing how the planet incorporates and repurposes. It also instructs in patience. To study it is to accept slow work, to wait for samples and for data streams that come in creaks and in bursts, to build knowledge out of marginal returns. The psychological effect is profound. Those who contemplate the trench in serious measure are often left with a mix of unease and reverence. Unease because the planet hides so much, reverence because the work of uncovering those secrets is the rarest form of listening. Disciplined, technical, and profoundly attentive, the trench also reshapes how humanity imagines its own ancient reaches. Many speculative narratives imagine lost civilizations erased by cataclysmic events, floods, cometary impacts, sudden climate shifts. The Mariana, however, suggests a different model of loss, one of slow, permeating assimilation. Memory does not have to be violently annihilated to vanish. It can be folded into geology, diffused into chemistry, spread too thin to reconstruct. That kind of loss is quieter but more total in the long span. It asks new questions of archaeology and of geosciences alike. How many human chapters have been reread as elemental layers instead of histories? How might the record appear if a human presence lasted a few thousand years and then disappeared? The trench, and places like it, keep the answer as an exercise of both hope and restraint. There is also, unexpectedly, a moral echo in this deep place. If the planet can so easily fold a civilization into itself, then the current human impact, the plastics, the isotopes of nuclear tests, the CO2 spike, becomes a different sort of inscription. These are marks that, in some cases, will persist. Some synthetic materials resist decomposition for millennia. Certain isotopic anomalies from the Anthropocene will be detectable in future sediment layers as unmistakable signs of a global species altering its context. The trench may act in a forward-facing archival role as well as a backward-facing one, collecting modern artifacts and burying them with the same indifferent consistency it uses to bury everything else. To witness the Mariana Trench in thought is to reconcile these twin images, the earth that forgets and the earth that remembers. The human mind, trained by novelty and immediacy, is always tempted to treat the abyss as a blank canvas on which to project grandeur or horror. But the deeper truth is more patient and more humble. The trench is a slow registrar of events, a place that insists on time as a medium and that asks every visitor, whether instrument or imagination, to learn how to read. No frequency histories. It offers no simple drama, no cinematic ruins. Instead, it offers a layered, granular narrative about existence under scales larger than those of cities and empires. That is why the first part of any story about the deepest place on Earth must begin not with a camera cut, but with a question. What does it mean to be lost to time? The Mariana Trench does not supply an answer so much as it frames the terms of the question. It tells of a planet that recirculates itself, that writes over and rewrites, that preserves and destroys with equal apathy. For those who listen carefully to the recorded sounds of the deep, who coax signals out of sediment cores, and who send instruments down with hope and trepidation, the trench is both a riddle and a kind of pedagogue. Its darkness is not malevolent. It is merely deep, inscrutable, because it is patient beyond human reckoning. The true sensation, then, is this: to stand at the lip of that abyss, perhaps only metaphorically, as a mind turned downward, and feel the small, sharp awareness of transience. The chilled air of perspective replaces the warm air of assumed permanence. In that exchange, the Mariana Trench teaches a discipline of curiosity that is more listening than seeing, more archaeology of time than of objects, more humility than triumph. It is at once the deepest place on Earth and one of its most eloquent reminders of how brief human stories are beneath the long, slow compression of the planet's own memory. What does it mean when the idea of deep becomes a ledger of human actions as much as a measurement in meters? A single image settles the question with terrible clarity. A fragment of manufactured plastic, folded and color-bleached, lying on the mud of the planet's lowest place. The image is both trivial and obscene. Trivial because it is only a plastic bag, obscene because of where it is. Found 11 kilometers down, where sunlight has never touched, and where pressure presses like the slow hand of a giant. That scrap is proof that the record of human presence reaches farther and deeper than anyone once imagined. The dives of 2012 and 2019 read like landmarks in this new understanding. They were not the first attempts to touch the Challenger deep, but each was a different kind of encounter, one of curiosity and cinematic yearning, another of systematic, almost industrial probing. Both returned. Not only footage and sediment, but also a set of revelations that unsettled the tidy comfort that the deep ocean was. Immune to human trivialities, the things they brought back were not dramatic, no golden idols, no perfectly preserved cities. They were smaller, stranger, and far more telling, living creatures that existed under conditions many thought impossible, microbes that read chemistry where sunlight provided no script, and, perhaps most disturbingly, artifacts of the surface world carried down by currents and time. The 2012 descent arrived as an act almost of private myth-making. A custom-built submersible surrendered itself to the abyss and sent back images that looked like alien worlds. Its lights cut thin cones through absolute black, illuminating amphipods like silver comets skirting the lens, and revealing soft structures that might be described as gardens of tube worms or carpets of xenophyophores, single-celled. giants that resembled moons of foam. The visual language was spare but eloquent, slow movement, bioluminescent punctuation, sediment that uncoiled in the wake of a probe like smoke. The submersible returned with samples, coarse sections of mud, slivers of organisms, sloshing jars of water and microbial soup, and the laboratories ashore were the first place the real conversation began. Those laboratories became stages for a slow kind of astonishment. Under microscopes, the mud revealed an entire unseen economy, microbial communities, not simply surviving but metabolizing in the absence of sunlight, were discovered in compositions and concentrations that forced scientists to reconfigure their assumptions about where life could be sustained. DNA sequencing of the samples produced fragments that did not match neat entries in existing catalogs, new lineages, odd metabolic pathways, organisms that preferred heavy metals or chemosynthetic diets. The sensory reaction was not triumph so much as reverence, an awareness of being secondary observers to a system older and more inventive than mythology had allowed. Between the awe, however, there was another, colder emotion. When technicians sieved through recovered materials, they found man-made detritus. In 2012, there were hints, fibers that did not belong to natural detritus, microplastics too fine to have been in the ocean before the Anthropocene. It was a first prick of realization. The deep sea, while remote and extreme, was not a sanctuary insulated from human mess. By 2019, the idea was no longer an unease, but a fact with texture. A different series of expeditions used a new generation of submersibles and remotely operated vehicles that could repeatedly reach the Hadal zone with greater payload and precision. Cameras were higher resolution. Robotic arms could collect targeted samples without turning the seabed into a muddled landscape. Sediment cores returned long, unbroken columns of mud that were sliced and scanned like the pages of an enormous book. And the book contained notes no one wanted to read. Among the objects brought up by the 2019 missions were unmistakably modern: a plastic bag, a candy wrapper, fragments of nylon netting, bits of filament that betrayed manufacture rather than natural origin. These objects were not shiny. They bore the marks of their descent: abrasion, mineralization, a pallor from long exposure to the chemical stew of deep water. Yet their presence at the bottom of the world announced a new fact about preservation in deep time. Some traces, especially synthetic ones, are stubborn. They do not dissolve into the archive as readily as organic matter. Instead, they persist, slow ghosts that will likely enter the sedimentary record and remain legible for centuries, perhaps millennia. The shock was amplified because of where these items were found. For decades, myth and hope had held that the deepest trenches might be refuges for records lost elsewhere, places where artifacts could be sealed by anoxic mud preserved against weather and war. The counter-image, now sharpened by the finding of modern debris, is of the deep as an indiscriminate sink. It is an archivist that has two hands, one that can seal and preserve a shard of pottery under perfect conditions, and another that receives industrial detritus and stores it with equal indifference. The trench does both, but the moral valence lies in the realization that what humanity leaves behind is not ephemeral in all directions. The geological memory will read back a signal of the Anthropocene, and it will be unmistakable. This was not merely an emotional reaction, it carried scientific consequence. The sediment cores from 2019, when subject to chemical assays and particle analysis, revealed microplastic concentrations far beyond anecdote. Microscopic beads, fibers, and fragments were embedded in laminations of mud, their distribution mirroring the slow rains of particulate matter from surface waters. Isotopic analyses showed shifts in elemental ratios consistent with an industrial age, heavy metals associated with modern metallurgy, signatures of combustion and pollution. Even if stone monuments were to be swallowed by tectonics, the geochemical fingerprints of human industry would endure in ways previously unappreciated. The biotic discoveries also reframed scientific questions. Organisms collected from these depths challenged assumptions about metabolic rates and body composition under crushing pressure. Many were gelatinous, lacking heavy calcified structures that would be disadvantageous under those forces. Others displayed adaptations so specific that they read like the answers to a series of impossible exams: membranes composed of lipids with shifted saturation, enzymes that function at temperatures barely above freezing, proteins with structures resilient to deformation. The DNA of some organisms contained sequences that hinted at ancient lineages, possibly relics that had diverged from shallow water relatives millions of years prior. The Hadal biosphere, it seemed, was not a scaled-down version of shallower ecosystems, but a distinct theater of life. With its own rules and histories, there was also an acoustic story. The descent, is a slow audio translation, the hum of pumps, the popping of pressure equalization, the chatter of instrumentation. But beyond the mechanical noise lies the trench's own voice, the distant rumble of tectonics, the micro-impacts of sinking particles, and the faint signatures of marine mammals far above. For researchers, listening became as important as seeing. Passive acoustic monitoring during the 2019 missions picked up frequencies that suggested not a bustling neighborhood, but a low-traffic, high-stakes environment where every sound mattered, where opportunity arrived seldom and was consumed thoroughly. The audio recordings folded into the narrative, a sense of temporal patience. The deep does not rush to respond. It archives events in low bandwidth increments. Emotionally, the findings inspired ambivalent responses that complicated the simple arc of discovery. For some, there was renewed wonder, the sense that Earth continually surprised through resilience and innovation in life's adaptations. For others, the revelation that human waste had penetrated into the planet's most remote fold was a quiet, accumulating shame. That shame was not only about litter, it was about permanence. When a trivial product designed for moments finds its way into sediments destined to outlast empires, it reframes the ethics of production and disposal on geological scales. Beyond the emotional, the scientific implications extended into speculative questions about deep time and lost civilizations. The trench's dual function as eraser and archivist suggested that the planet might both conceal and preserve traces of advanced activity in unpredictable ways. A city made of perishable materials could be turned into chemical anomalies of populations. Combustion could leave isotopic scars. Durable synthetics might be preserved almost intact. The 2012 and 2019 dives did not provide evidence of any mythical prior humanity, but they reframed the question: if traces of past technogenic activity could be erased by subduction, they might still be legible in unexpected chemistries. The deep did not promise clarity, only a new kind of palimpsest. It was also a methodological lesson in these missions. The deep is so physically and chemically different from surface environments that discovery required instruments honed for restraint and precision, robotic arms calibrated to avoid disturbing entire thin laminations of mud, corers designed to extract contiguous columns without introducing contamination, lab protocols established to prevent modern plastics from being misinterpreted as ancient inclusions. These were the technical countermeasures born from the shock of finding modern debris in Hadal deposits. In other words, the very act of detecting contemporary contamination forced scientists to develop cleaner, more rigorous pathways for reading the planet's subsurface narrative. The presence of human-made objects at 11 kilometers depth also altered the public imagination. The romantic notion that the deep is a vault of lost treasures gave way to a more uncomfortable awareness. That human impact had already pressed its signature into the deepest chapters of the planet's history. Documentary narratives shifted tone. What had earlier been stories of triumphal descent became cautions on stewardship and humility. The deep sea, hitherto remote in mind, became a place of consequence for collective decision-making. If the trenches could serve as accidental museums for modern detritus, they might also become intentional repositories for thinking about legacy. What kind of stratigraphic message did humanity wish to send? Yet beneath the ethical knot there remained a quieter, more profound lesson. The Hadal discoveries forced an adjustment in temporal perspective. Humanity's acts reverberated not only forward in time, as in climate change and plastic pollution, but backward in the sense that the trenches could now serve as archives of contemporary life. In future epochs, when only the planet's geology could be read, laminae laid down in the Anthropocene would contain unmistakable signatures of this moment. The deep is thus both repository and critic. It accumulates the physical residues of human life while simultaneously rendering judgments in the neutral currency of geology. The 2012 and 2019 expeditions, taken together, made the Mariana Trench more than a point on a map, became a fulcrum for thought, a place where curiosity, shame, reverence, and scientific rigor collided. The objects and organisms they returned did not resolve the larger speculations about erased civilizations, nor did they produce a tidy narrative of human intrusion. Instead, they complicated the moral and epistemological terrain. The deep was neither blank slate nor impenetrable cipher, but a place where the temporality of human action and the patience of geological process intersected in ways that would be read and misread for generations. In the end, the most unsettling takeaway was not any single artifact brought to the surface, but the composite image they created. A world where life persists in forms adapted to crushing pressure, where microbes and microbes' chemistries rewrite expectations, where synthetic detritus can outlast the durations of marriages and empires alike, and where the planet itself alternately buries and preserves humanity's traces. The lastness of that image is not cataclysmic but accumulative, a slow, inexorable inscription into the planet's slow book. The abyss, once treated as the ultimate boundary beyond which nothing of us could reach, had become an archive in its own right, a place that would remember when much else had been forgotten. What does silence mean when it is not nothing? That paradox sits at the center of any serious approach to the planet's deepest reaches. Silence is a quality of the senses, not an absence of content. The Hadal darkness, the cold, pressurized world below the sun's reach, behaves like outer space in some respects. Both are places where ordinary senses fail, where air and light and casual sound offer no purchase. Yet neither is empty. Each is a medium threaded with signals, gestures, and histories that demand instruments and imagination to perceive. When listening devices are lowered into those depths, the first impression is often of very little, a thin, low graze of tectonic rumble, the faint hiss of particulate rain, the distant, slow tempo consonance of currents. But the quiet is not uniform. Embedded in the broadband hush are textures, and within those textures, repeating articulations that arrest attention. Hydrophones and seafloor recorders, designed to be patient, pick up sequences that recur over hours, days, even seasons, rhythms with a constancy that seems to imply purpose. The recordings arrive as rows of waveforms and spectrograms, bands of energy at precise intervals, pulses whose envelopes neither mimic simple mechanical knocks nor the irregular chatter of storm-swept seas. They appear at first like messages left on an answering machine by a voice that chooses to speak only in punctuation. The deployment of the listening apparatus itself is a small drama of restraint. A weighted frame drops from the research vessel as the ship's winch groans and the cable pays out. The instrument package, a cylinder of titanium and polymer, its hydrophone membranes tuned to pick up frequencies below human hearing, descends to a column of water that grows colder and more attenuating with every meter. The voyage is slow, each meter of cable a small concession to pressure. When the frame finally touches the mud, gravitational tugs calm the winch, and a faint ping passes along the fiber optic link that testifies to successful contact. Then the recorder begins to be patient. It does not seek drama. It listens, yearns for no applause. Over weeks it collects small events, a slump of sediment, a transient purr from a passing whale far above, the tiny percussion of microseism-driven sediment cascading like distant gravel. Within those collected events, the repeating sequences emerge. They are not always the same. Sometimes they are a series of short, sharp clicks clustered in rhythmic trains, spaced with the exactness of a metronome. At other times, they are slow, pulsed tones that rise and fall on a timescale measured in minutes, a kind of breath. Spectrograms illuminate these patterns like constellations on a new map, a line at 3 Hz, an alternating harmonic chiming at intervals of 20 seconds, a modulation that suggests information shaped rather than noise. The instinct that accompanies a first encounter with such data is twin-edged. One part of the discipline reads each pattern against catalogs, the known song of a species, the signature of a vent release, the frequency imprint of a mechanical source. Another part, older and more human, asks a larger question. Could these be messages? The question is irresistible because the mind is organized to find agency in pattern. Throughout human history, repeating signals became language, ritual, and law. In the trench, however, the anthropocentric leap from pattern to intent is perilous. Many natural processes produce strict timing, the cyclical opening of a thermogenic orifices, the rhythmic collapse of methane bubbles escaping a hydrate, the periodicity of tidal shear at a particular bathymetric notch. Yet there are also biological systems that organize movement and sound into regular assemblies. Bioluminescent organisms, for instance, often flash in synchrony as part of mating displays or as communal defense. Many deep-sea species combine visual signals with mechanosensory or acoustic cues, creating multimodal performances that read as both sound and light. That multimodality is crucial to understanding the trench's communicative ecology. Even where no sunlight reaches, life has invented luminous languages. In the blackness, some organisms carry their own photons as instruments of notice. The phenomenon is not mere ornamentation. Bioluminescence functions as lure, as alarm, as code. In the Hadal zone, where food arrives in rare parcels and predation is costly, signal efficiency is premium currency. It is in the economy of efficiency that the patrol-like movements of luminous life take on meaning. Imagine, through the slow, humming cones of a submersible spotlight, a canyon wall mottled with pinpricks of living light. At first the lights seem random, isolated flickers like distant stars. But as the vehicle slides along the slope, a pattern reveals itself, trains of organisms moving in coherent bands, their bioluminescent organs lighting and dimming in synchronous cadence. They do not drift haphazardly, rather they sweep in arcs and lines as if following mapped routes. Some groups move along the same corridor time and again, maintaining spacing between individuals with mechanical precision. Others form ephemeral circles, luminous patrols that rotate and then dissolve, the glow dispersing like the wake of a pendulum. The sensation that these are patrols is an interpretive move, but it is not merely poetic. Mechanisms underlie the regularity. Certain siphonophores and colonial jellies travel in coordinated columns, their zooids acting as coordinated units. Aggregations of amphipods and mysids can create flow-stabilized strata, moving together in dense pelagic streams. Tube-dwelling worms on the sediment surface may flush in unison when stimulated, creating waves of light that resemble the sweeping beams of a lighthouse. The choreography has ecological logic. Moving in formation can concentrate foraging power, confuse predators, or maintain social spacing that reduces energy expenditure. In the trench environment, where resources are scarce and the cost of error is high, such disciplined movement becomes a survival strategy writ large. Acoustic recordings sometimes mirror these light patterns. Hydrophones pick up trains of short broadband clicks that correlate with observed luminous pulses. The clicks, when plotted against time, form remarkably consistent intervals, a unit repeated as if by a clock. In a few instances, low-frequency hums accompany the clicks, a subsonic wash that may mark the passage of a dense organism or the resonant vibration of a communal structure. These multi-sensory sequences complicate any tidy explanation. They suggest that the deep signaling repertoire is not accidental but bound by constraints and purposes, to say, to warn, to pick mate, to mark trails. They also complicate the notion of emptiness. The Hadal is not quiet because it is inert. It is quiet because its conversations are subtle, often at the edge of detectability. Interpreting those conversations requires humility. The researchers who parse the signals practice a kind of methodological modesty that is itself a narrative element in this world. Long nights of pattern recognition become communal acts of patience. Spectrograms are annotated in slow, careful strokes on monitors that glow like altars. Analysts adjust filters to peel away the low-frequency thrum of the earth and reveal the high-frequency chatter beneath. They cross-correlate acoustic events with visual records from remotely operated vehicles, aligning time codes and light signatures until a picture emerges. The emotional tenor of these lab sessions is a mixture: wonder at the unexpected, frustration at ambiguity, a creeping reverence that the planet's margins will not yield their meanings under a hurry. That reverence extends beyond curiosity. There is unease, a recognition that repeating signals might be legible not only by today's scientists but also by future beings. Reading the geological record, like synthetic detritus pressed into mud, behavioral regularities can leave traces. A persistent migratory corridor carved by luminous foragers could influence microtopography. Repeated feeding in the same trench corridor could bias sediment composition, leaving a detectable sequence of disturbance laminae. The idea reframes the trench from merely a stage where organisms perform to a material archive where those performances are sometimes inscribed. Within this archive, repeating acoustic signals raise a speculative possibility that transforms from the academic to the philosophical. If a simple rhythm can become a durable mark, a signature that might be preserved under the right conditions, then non-human. Cultures of pattern-making could participate in the deep's long memory. It is a subtle form of continuity. Where stone monuments do not endure, rhythms may. The planet is literate in many scripts: chemical ratios, isotopic anomalies, layers of plastic, biotubation patterns, and the sedimentary echoes of behavior. The trench teaches that the language of endurance need not be a single alphabet. There is also an ethical undercurrent to the listening work. The same tools that reveal delicate natural rhythms also expose the reach of human signal. Sonar pings, ship propellers, and the low-frequency hum of distant drilling show up in the acoustic record, sometimes masked by the more organic patterns, sometimes interrupting them. The presence of anthropogenic noise in the deep complicates interpretation. It also carries a moral resonance. For creatures adapted to an economy of quiet, human sound is an intrusion. It can alter patrol patterns, confuse mating calls, or mask the faint platelet-like clicks used for communication. The trench, which archives the physical debris of human activity, archives the acoustic footprint as well. The planet does not have moral outrage, but its record will testify. To approach the recordings without melodrama is to accept a scientist's discipline and an artist's restraint. Many of the repeating sequences that animated the first analyses eventually yielded pedestrian explanations: a hydrate cap releasing methane in laminar bursts, a current interaction chuffing at the lip of a canyon, the servo beat of a deployed instrument responding to a predictable mechanical driver. But some sequences resisted tidy classification. They remained stubbornly regular, their periodicity persisting even after instrument artifacts were ruled out, their correlated luminous signatures resilient across multiple observations. Those were the moments when the Hadal felt most like a theater of inscrutable practice rather than a gallery of known artifacts. In those moments, the narrative bent moves from explanation to attunement. The deep becomes a place that reveals how life elsewhere on Earth manages continuity without human scaffolding. Where monuments are ephemeral, organisms proliferate patterns that are themselves forms of persistence. Patrols of glowing organisms, when repeated across generations, instantiate a habitus, a behavioral tradition that occupies time. The trench does not only contain life, it contains practice. And practice, repeated, is a way of writing. That possibility encourages a new humility about how a civilization, any culture capable of leaving traces, might be read by a stranger peering backward through deep time. The archaeologist of the future, or the geologist excavating a palimpsest, might decode a series of structured acoustic artifacts as natural or misread purposeful patterns as meaningless noise. The Hadal acts as a corrective to simplistic assumptions. That the absence of stone temples implies the absence of sustained cultural technologies, or that silence implies a lack of intelligence. Silence is rarely nothing. Often it is patience. The listening deploys a final lesson. To discern the meanings in the trench requires an epistemic generosity, an acceptance that pattern does not always translate into agency in the human sense, but that pattern can sustain ecological intelligence that matters. The repetitive click, the luminous sweep, the long-lived patrol, these things are not human histories, but they are histories nonetheless. They are small, intricate chapters of endurance that the planet keeps in the way it keeps isotope ratios and shard fragments unevenly, selectively, sometimes ephemerally, sometimes with a stubborn materiality that will outlast empires. So the Hadal becomes, in thought and recording, a palimpsest of rhythms. The quiet is full. It is full of pulses that call and answer, of light that scans and returns, of an economy where every motion is costly and thus weighted with meaning. The recorded repeating sounds are not cosmic messages, and they are not empty beats. They are the grammar of persistence, sentences shaped by constraints, repeated so often that their echoes press into sediment and memory. In the trench, silence is not absence. It is a reserved room in which the planet speaks in a low, slow voice, the voice of systems that keep time on scales that make human sentences sound like footnotes. Listening to that voice requires patience, humility, and the willingness to hear that being alone in the universe is not the same thing as being empty. What does life look like when it has never evolved a face to be looked at, when visual spectacle is an expendable luxury, and every sensory economy is built around things humans cannot readily measure? That question arrives before description, because the discovery in the Hadal proved to be a lesson in humility. Not only had biology adapted to pressure and cold, it had rewritten the very grammar of form and movement. The creatures encountered, they were not merely strange in the sense of unfamiliar, they were strange in the sense of categorical difference. They suggested that the Earth could, in an extreme environment, assemble living things from a radically different toolbox. The first images that circulated looked like contradictions. Filmed under the submersible's floodlights, a shape would appear like a blank, iridescent smear, a body without a clear head, without paired limbs, a silhouette that refused symmetry. Closer inspection revealed layers and cavities, tubules and membranous folds arranged like a city seen from above, a chaotic skyline of organs that had no obvious pattern. Some individuals were long and irregular, tapering and bulging in place, their surfaces threaded with veins of translucent tissue. Others assembled as aggregates, dozens of lobes linked by delicate membranes, each lobe slightly different in size and function. The expectation of bilateral or radial symmetry, so familiar from shallow water taxa, collapsed in favor of asymmetry that read as architectural improvisation. Transparency was the other immediate striking attribute. Flesh melted into light in a way that made organs visible as pale ghosts moving under a skin that seemed to be liquid glass. Internal chambers pulsed with faint opalescence. Symbiotic microbes glowed intermittently like constellations within a nightless sky. The absence of pigment was at once practical and eloquent in a world where photons are currency of negligible value. Producing color is an expensive trick. Transparency reduced metabolic burden and offered concealment against bioluminescent predators. More interestingly, it revealed a principle of honesty, where sight is useless, showing the internal machinery may be a more efficient way to manage interactions with symbionts, parasites, and kin. A living transparency that makes internal states legible to those organisms that read chemistry and flow. Movement, when it came, shattered expectation. The camera's frame would capture a zooming close-up, and then, as if obeying an internal choreography, the creature would slide along the sediment, not by legs or cilia in any ordinary sense, but by orchestrating micro-vortices. Faint eddies, almost invisible, formed along the body and carried the organism forward. It was not propulsion through muscular exertion, but a reshaping of local fluid dynamics. Synchronous contractions of soft chambers would pressurize thin layers of interstitial water, generating shearing flows that lifted the body just enough to avoid friction and then pushed it forward in slow, deliberate saccades. In other cases, plating of mucus would be secreted and then rapidly hardened by ionic exchange with seawater, creating transient treads that the organism used to roll or glide. The effect on the viewer, human or machine, was of motion invented from the physics of the medium itself. A locomotion that treated the seafloor as a malleable partner rather than an inert stage. Some of the most confounding behaviors were the absences. Probing lights, the instinctive tool of deep-sea exploration, provoked no reaction. Pulses of bright LED that would trigger flares in bioluminescent species produced only a ghostly, indifferent shimmer in these bodies. Attempts to elicit electrical or magnetic responses, small EM sweeps deployed from remotely operated vehicles, were, similarly, met with null results, where many deep organisms display sensory systems that register the faintest change in photon flux or electromagnetic fields. These creatures seemed deaf and blind to those modalities. They did not recoil, they did not close, they did not flash. It was not fear, it was oblivion in the literal sense. The stimuli that human instruments prioritize simply did not have the currency to register. The absence of response forced a shift in experimental protocol. Where optics and EM had been primary, researchers began to treat mechanical and chemical cues as first-class signals. Gentle, sub-millimeter perturbations of the sediment, a barely perceptible pressure wave, a micro-bubble release, or a cloud of dissolved amino acids were used as tests. Some organisms answered these probes like compasses drawn to iron. A microplume of amino acids released into the water column could trigger coordinated undulations across an aggregate, a wave of membranous folding that brought external surfaces in contact with a nutrient-rich eddy. In a few cases, a pattern of low-frequency pulses transmitted through the sediment produced synchronous contractions across a group, as if the organisms had evolved to hear through the ground rather than through water. The sensory ecology that appeared was tactile and chemosensory before it was visual or electromagnetic, a world of taste, touch, and shear. That sensory permutation has profound consequences for how life is detected and how its histories are read. Many deep-sea exploration techniques depend on the opacity of biology to certain bands, optical imaging, bioluminescent elicitation, and electromagnetic tagging. If a significant branch of life is indifferent to those stimuli, it becomes easy to miss or misinterpret. Sediment layers may be thick with activity that leaves no obvious optical signature. A corridor of persistent grazing, where a population smooths and resculpts the mud in a characteristic pattern over decades, can be invisible to cameras yet legible in microtopographic surveys and in chemical stratigraphy. The Hadal, then, contains a literate diversity written in scripts unfamiliar to modern senses. Asymmetry, in particular, seemed to be a recurring theme with functional consequences. Uneven body plans correlated with localized resource landscapes, where geothermal microseeps released pulses of reduced compounds like sulfide or iron. Clusters of asymmetrical individuals extended elongated lobes into the plume zone, their mouths, if they could be called mouths, acting as fixed filters that funneled chemistry into internal chambers. Other asymmetrical forms had ridged undersides that matched the microgeometry of persistent current eddies, as if their bodies had been pressed and grown into the hydrodynamic contours of the seafloor. In some places, aggregates of these creatures coated the mud in a patchwork, each patch specialized, a living mosaic in which an organism's shape was a map of local gradients. The result was a terrain of life that read as both ecology and cartography. Microscopy and molecular analysis revealed further oddities. The tissues, though translucent, were dense with a diversity of symbionts, bacterial consortia that carried out chemosynthetic metabolisms, archaeal lineages tuned to heavy metal reduction, and strange viral assemblages. Many of the host genomes were littered with horizontally transferred elements, genes for lipid composition and pressure resistant. Proteins appeared in mosaic patterns that suggested frequent exchange among community members. Metabolic pathways emphasized refractory compound recycling rather than the classic photosynthetic-derived sugar economies. Enzymatic machinery functioned at pressures and ionic milieux that would denature shallow water proteins. Lipids were enriched in polyunsaturated chains with unusual stabilizing crosslinks. The molecular picture was one of tight interdependence, organism and microbe forming composite machines adapted for steady scarcity. Beyond the immediate biological interest, these discoveries reframed old questions about preservation and record-keeping on geological timescales. If organisms were built to be transparent and to recycle everything, what would they do when encountering manufactured matter? Observation suggested they could both obscure and annotate. Synthetic fragments, microplastic filaments, metallic flakes, when trapped in mucous matrices, were sometimes incorporated into the organism's body surfaces. In a few filmed instances, a filament woven into a mucous petal became a scaffold upon which calcified microbes eventually deposited minerals, creating a microlithic accretion encasing human-made materials. The implications were twofold and unsettling. Synthetic detritus does not merely rest inert in the sediment, it can be taken up into biological cycles, altering both organismal physiology and the material signature that will be left for future geologists. The creature's indifference to light and electromagnetic perturbation also carried a speculative weight that extended beyond biology into epistemology. The modern habit of defining life by the senses, human tools, privilege, vision, radio signals, electromagnetic biomarkers, is culturally specific. The Hadal assemblages suggested alternative sensory hierarchies where patterns of shear, gradients of dissolved organics, and the slow accretion of mechanical marks are the currencies of meaning. If that is true on Earth, it has consequences for the way scientists imagine life elsewhere. On other worlds, life may evolve to innately ignore photons or radio frequency signatures. It may prefer gradients of pressure, ionic fluxes, or particulate drift. The Hadal thus functions as a local laboratory of epistemic humility. It warns that the search for life is intrinsically biased by the senses it uses. That humility extended into the practical work of description. Start! Instrumentation developed an aesthetic of restraint. Cameras were mounted with filters that minimized glare and induced fewer false positives of bioluminescence. Water pumps were tuned to whisper so as not to generate mechanical artifacts. Chemical dispensers spread puffs of nutrient with microliter precision. The narrative of discovery in this environment became a story of slow adjustment, a negotiation between human curiosity and Hadal's own modes of being. Where earlier approaches broadcast into the abyss with lights and pulses, the new practice was to listen with gentleness, to nudge, to watch the sediment settle, to measure the non-response and learn from it. There was also a social affect among the collective of researchers, a recurrent oscillation between awe and anxiety. Awe at the ingenuity of forms that reimagined locomotion and sensing, anxiety because those same forms refused the familiar cues that undergird much of scientific inference. The Hadal creatures exemplified a broader unease about inference under deep time conditions. If biological innovation can produce bodies that escape optical detection and leave no obvious fossil cast, then the narrative of the planet's past is even more incomplete than assumed. The absence of evidence in stone may be absence, or may be the result of forms whose histories are written chemically and behaviorally rather than lithically. This realization fed into the larger speculative framework of the project. The trench, previously imagined as an eraser or an archivist, now acted also as an engine of obfuscation, an ecosystem that can incorporate, alter, and re-encode signals in ways that make teleologies difficult to recover. A settlement of perishable dwellings, if it were swept into Hadal depths and colonized by these organisms, might leave chemical seasonings in the mud, microbiomes keyed to introduced materials, and altered bioturbation patterns rather than recognizable architecture. The traces preserved would be subtle, dispersed through microbial genomes and sediment chemistry, legible only to those who had learned to read, non-visual scripts. Yet within that difficulty lived a quiet optimism. Discovery compelled the development of new proxies, microtopographic mapping to identify pathways of repeated movement, compound-specific isotopic analyses to detect non-endogenous carbon signatures, long-term acoustic and mechanical monitoring to reveal repeated behavior that, over centuries, might become a stratigraphic mark. The Hadal's alien life demanded a wider array of attention. In learning to attend to friction and taste, to time scales of centuries rather than hours, the scientific gaze widened. The epistemic expansion was itself a kind of enrichment. To know that life can choose to be invisible to light is to broaden the possibilities of what stories the planet might still hold. In the final analysis of the discoveries, the Hadal organisms stood as a parable. They taught that form follows niche in the most literal sense, that life will find economies in physics that humans cannot intuitively imagine, and that the planet's archive is written in many registers: transparent flesh, asymmetrical architecture, locomotion forged from fluid physics, and a sensory world centered on chemical and mechanical signals. These were not curiosities to be consigned to oddity cabinets. They were pivot points for rethinking, detection, preservation, and the very categories used to adjudicate presence in deep time. The Hadal, in this light, was not merely a sink for human artifacts or a slow eraser of monuments. It was an ecosystem that questioned the instruments and metaphors humanity brought to the deep. It required patience, humility, and a willingness to be surprised by life's inventiveness. And because it also hinted that signatures of the past might be written in behavior and chemistry rather than in visible structures, it extended the Trench's lesson. To read the Earth's long story, one must learn new alphabets, attuned to different senses, and accept that silence and indifference can themselves be information. What does it mean when an instrument that has been assigned the duty of witnessing simply stops speaking? The question is not rhetorical. In the context of the Hadal, where every returned datum is a small miracle of engineering and patience, a sudden lapse of communication becomes a data point and a fissure in narrative at once. This was the shape of the event, a clean, ordinary telemetry stream that had been carrying depth, pressure, temperature, battery levels, and a continuous video feed. And then nothing. For 27 minutes the device was blind to the world above. For 27 minutes the ship, the shore laboratories, and the people hunched over their consoles received no translation of the physical reality occurring 11 kilometers beneath the waves. The broadcast that preceded the silence had been unremarkable. The camera's lamps illuminated a slope of coffee-fine mud and occasional outcroppings of rock, an ecology of pale, gelatinous organisms in the slow, dignified fall of particulate matter like a continental snow. Instrument readouts sat in tranquil numbers. Then, as if in punctuation, the pixels froze. Telemetry continued to log a heartbeat of power draw that did not materially change. The tether's tension, the cable's strain gauges, the spool counters registered continuity. No alarms fired. The ship's operators watched the single, stubborn black frame where moments before had been the slow choreography of the Hadal floor. The first instinct was technical, to assume a fault that could be diagnosed and patched. Touchscreens were tapped, status windows refreshed, handbooks thumbed. Reboots were planned even while engineers ordered calm. Yet when the usual battery and cable checks returned their usual green, when the instrument's internal diagnostics reported no fault, the silence took on a different gravity. Silence, in this region, is not merely the absence of recorded sound, it is the loss of testimony. The device had consented to be a human eye and ear at an impossible depth. Its failure to report was suddenly a failure of custody. Those watching felt a peculiar constriction, a gap in a history being slowly written in silt and glow. The long minutes fell like a drum count. Time in the control room became elastic and odd. Clocks cycled. Coffee cooled and was abandoned. The people present, not characters in a drama so much as a dispersed human presence, performed rituals of protocol without the comfort of narrative closure. Ping the connection, send the handshake packet, cycle the lighting algorithm, dispatch a command to raise the camera's iris. Each attempt, each line of code, carried with it a small existential wager that the machine would resume and that no mystery had intruded into its frame. With each failed attempt, collective panic was translated into disciplined procedure. Yet anxiety threaded through the calm. The long hush, the waiting, took on a texture far beyond the technical. When the stream resumed, the return was not triumphant, so much as uncanny. The video feed came back not with the same composition, but with an alteration. The device had moved. The angle of the sea flow was different. The frame captured a new set of organisms at an unexpected proximity. and the instrument's legs, where visible, sat in a slightly altered relation to the sediment. There was no dramatic sweep or violent upheaval. The camera was not toppled. Instead, the scene suggested a subtle relocation, a few meters of translation, a small rotation, the faint scrape of the transducer housing across the mud. That translation was a compound problem. Movement at that depth must be accounted for by physics. Either a force acted on the instrument, an external agent, or the instrument acted on itself, a self-induced motor function, thruster or winch, or the substrate beneath the device gave way. Each explanation carried a catalogue of expected signals. A current strong enough to shift the instrument would have been registered by the adjacent current profilers and by the tether's tension record. A bottom slump would have triggered microseismic events and produced a telltale signature in pressure sensors. An autonomous activation would reveal a control command sequence in the device's logs. None of these signatures were present. Investigators then turned to the video frames both before the blackout and after it. High-resolution pixel differencing techniques were used to parse the faint differences. Optical flow maps were constructed to estimate motion within each frame, and three-dimensional reconstruction software produced a coarse bathymetric model of the immediate scene. What emerged was both granular and puzzling. The traces on the mud, when magnified, showed an asymmetric pattern, a shallow furrow, a smudge of displaced particles along one side, and a thin, pale film adhering to an exposed surface of housing. There were no tracks in the sensuous sense, no deep gouges, no impressions of claws or of anything clearly mechanical. Instead, there was evidence of contact that had not been violent enough to topple or break the assembly, but intimate enough to redistribute the finest fraction of sediment and to deposit a coating on polished surfaces. Here, the interpretive economy expanded into speculation and method. A long list of potential causes was considered and dismissed in turn, each hypothesis tested against the data. Could a large animal have brushed the instrument like a whale of the abyss? Such an organism would likely have registered acoustically, and the hydrophone array had not recorded any such passing. Could a sheet of methane hydrate have released and lifted the device by buoyant force? Methane releases leave a unique chemical and acoustic fingerprint. They were absent. Might an autonomic instability within the instrument have produced a thruster activation? Command lobs were clean. The substrate collapse theory, which had at least an aesthetic plausibility, foundered on microseismic records. No slump event was recorded. The available instruments, in aggregate, declined to explain the most parsimonious explanation. A physical influence translated into displacement without the expected collateral signatures. The absence of a neat technical cause made room for more subtle readings. Analysts turned to the film on the housing. Its composition was tested with spectrometers. The results compared against databases of known biological exudates, of mineral precipitates, of lubricants and industrial compounds. The film registered as organic, with spectroscopic features suggestive of complex polysaccharides and a scattering profile, consistent with a mucus matrix rather than a mineral gloss. It was thin, translucent, and patchy. If the deposit had come from a biological source, what could that source be? The Hadal's life, late and lean, has shown capacities for both surprising rapidity and slow, almost geological persistence. Could a congregation of organisms operating in a band or a swath have moved past the device and, in their passing, pushed or nudged it? If so, their collective motion would have needed to act with a coherence and force beyond what had been documented elsewhere. A second line of evidence complicated matters further. Tiny particulates adhering to the film bore microfossil fragments that matched local planktonic species, but in ratios that suggested a recent concentrated deposition rather than a slow, steady rain. That is to say, some process had concentrated particulate matter during the blackout window. The temporal coincidence, a brief absence of telemetry followed by a local enhancement of particulate deposition and a slight displacement, read like an event, but the instrument arrays that would have recorded the mechanical act simply did not agree on. What that event was, beyond the pure mechanics, there was the psychological continuum. The 27-minute silence took on a symbolic weight. 27 minutes is an arbitrarily small span in geological terms, in human terms, particularly in the cramped, deadline-driven world of data collection. It is an eternity. The pause fractured the sense of linear witnessing. It offered a reminder of the limits of being present in a place that insists on patient, extended attention. For those guarding the instrument logs, the silence was not merely a recording gap. It was a moment in which the Hadal had withheld its testimony. The effect rippled outward. Conversations in labs leaned toward humility, toward metaphors of the deep as an interlocutor that could choose to be mute. That Interpretive humility is crucial to any documentary account of the deep. The Hadal resists human methods because its languages are often not the ones instruments are designed to translate. Whoa! The earlier parts of the expedition had revealed creatures whose lives were written in viscosity and chemical gradients, organisms indifferent to photons and responsive to shear. The same sensory economy may allow physical events to occur that register dimly on human-designed detectors. A band of organisms moving as a dense collective can create a flow field that, to a tethered object, registers as pressure without producing a distinct sound. A thin mucus film secreted en masse might reduce friction just enough for slow creep to move a mass across silt. These are hypotheses couched in the language of ecological plausibility rather than of engineered certainty. The event also reopened older questions about the act of observation itself. Instruments are not passive witnesses so much as active participants in the environments they sample. Lights alter behavior, thrusters disturb sediment, cables present foreign geometries that organisms can bump into or avoid. In many ways, the most honest conclusion was a modest one. The presence of the instrument had altered the environment in ways that could not be fully disentangled from the displacement. The Hadal's residents, whatever their phylogeny and physiology, had opportunities to engage with an object that was neither rock nor organic tissue. How they chose to engage, to brush, to adhere, to flow around might have been a function of their sensory priorities, which are not human. Yet it would be insufficient to reduce the episode to a lesson about observer effect. There remained empirical stubbornness. A mucus smear is not a machine-moving force. The site's microtopographic mapping, reconstructed after the event, showed a subtle radial arrangement of disturbed sediment that suggested not a single pass but a series of contacts. Light nudges repeated enough to ratchet the instrument along. The pattern resembled the way multiple small pushes can move a heavy object more efficiently than a single larger shove. If such a process had occurred, it required repeated, coordinated interaction, a collective agency of small forces acting in serial. That suggestion is disquieting because it sits at the border between behavioral ecology and the sociology of scale. Individual agents and the deep acting together to produce macroscopic change. The investigators expanded the frame. Long-term monitoring was adjusted. Cameras were repositioned to look away from the instrument as well as toward it, in hopes of capturing the body of the movers instead of merely their wake. Hydrophones were retuned, and mechanical sensors with micronewton sensitivity were deployed to record the faintest of tangential forces. Sediment traps were reset and allowed to collect for longer intervals. The research program acquired, in a single unexpected disruption, a new imperative: to design experiments that could reconcile the mute, the visible, and the measurable. Because the Hadal archives operate on a different temporality, the 27-minute window became a calibration exercise for thinking in other scales. What looks like an anomaly in human time might be a signature behavior in geological time. A process that nudges an object meters over minutes could, if repeated over years, produce a displacement that in the sedimentary record becomes indistinguishable from geomorphological drift. In other words, small biological acts could be agents of persistent change. That insight folds back into the larger speculative question the project pursues: how does the planet record activity? And how many forms of that activity fall beyond the gaze of conventional archaeology and geology? The aftermath of the blackout did not produce answers so much as it expanded curiosity. The film on the instrument remained a thin, insoluble trace that pointed toward biological agency but offered no conclusive fingerprint. The displacement remained measured and real but inexplicable within the expected catalogue of causes. The silence taught the team, the notional assembly of observers and analysts, that absence of signal is not neutral. It is a component of a story. It can indicate breakdown. It can indicate danger. It can indicate that the environment temporarily refuses to be translated by the tools at hand. And it offered a deeper lesson. The Hadal is a theater of low-bandwidth events, where significant processes can be compressed into small windows that demand both patience and interpretive humility. To make sense of such windows requires a willingness to let the instruments teach new grammars. It also requires a philosophical patience to accept that some passages in the planet's logbook will remain partially occluded, and that these occlusions are themselves meaningful. The 27-minute silence was not a failure in human technology alone, but a moment of contact where human attempts at witnessing collided with a theater governed by other logics. In the control room, the white noise of ship systems returned to its usual rhythm. The sample cues were reorganized. The camera's lens, scrubbed and inspected, was redeployed. The event had shifted something more intangible, the narrative tone. The deep had reminded its observers of its capacity for the unanticipated and of the narrowness of instruments designed for other regimes. The investigators left the site with new protocols and renewed caution. They also carried with them a small, persistent question: if a simple instrument could be moved in silence, what other small but persistent acts of the Hadal had already been reshaping the record of the planet in ways that human timeframes had not yet learned to read? The answer would have to wait. Trench, patient as always, kept its long calendar. The 27 minutes had closed, the telemetry streams resumed, and the slow work of translating dark into meaning continued. The incident persisted in the memory of the project, not as a solved anomaly, but as a small allegory, a reminder that in the deepest places on Earth, silence, movement, and mystery are braided together, and that the attempt to witness is itself an exercise in humility before time and habit. What does it mean to encounter geometry where none should exist, a right angle folded into the planet's skin, a flat face cut with the deliberateness of a stonemason, a silhouette that reads more like an instruction than an accident? The question arrived like a cold wind across the bridge of the survey vessel. Nah! A line on a screen that refused to be smoothed away by plausible explanation. For the long, patient conversation the Mariana had invited, of sediment cores and laminae, of microbes and microplastics, of slow, anonymous processes. This was a punctuation mark that demanded a different grammar. The discovery began in the language of instruments. A routine mapping pass using the ship's long-range synthetic aperture array and side-scan units produced a return that did not fit standard models. The profile looked like a block, plainer faces, acute edges, shadows cast with the crispness of a man-made object. In plan view, the feature sketched near-perfect rectilinear lines. In cross-section, it rose approximately 30 meters above the surrounding sea floor, a prominence that broke the otherwise gentle topography of the trench's floor. The data stream, dense, decades calibrated, and freighted with professional skepticism, registered the object's outline with a clarity that silenced the usual first reaction: instrument error. The first minutes after such a detection are always practical. Multiple passes were plotted. The ship altered heading and speed to sweep the area with different incidence angles, to verify that the hard line on one pass was not an aliasing artifact. A sub-bottom profiler, the device to compare into the topmost meters of sediment, was run. Magnetometers and gravimeters were engaged to read the field signatures that might hint at dense metal or anomalous mass. Analysts in the acoustics lab reprocessed the raw pings, applied different beam-forming algorithms, adjusted for the angle of incidence degradations that come with extreme bathymetry. Each reprocessing returned the same stubborn geometry. Across the network of screens, a spectrum of emotions played out, not as theatrical beats, but as a series of shifting registers. The clinical curiosity of method, the narrow spike of excitement at seeing something novel, a low, corroding unease born of what such a shape implied. The team had rehearsed contingency protocols for odd returns, false positives, wrecks, bright patches of hard ground, but this reading did not sit easily in any familiar category. The geometry and the lack of obvious causal processes for it tugged on a more dangerous human reflex, imagination outrunning caution. The object's acoustic signature provided the first real puzzle. Typical basaltic outcrops, pumice fields, and rock collars reflect sonar energy in characteristic ways: a certain high backscatter, predictable attenuation, an energy decay curve tied to roughness and composition. The block returned echoes that were oddly smooth and specular, more like a polished surface than a fractured basalt face. The sub-bottom profiler, which was expected to reveal layered sediment resting against the object, registered an abrupt impedance contrast at the object's boundary, but no internal layering consistent with igneous mass. Sediment that had accumulated adjacent to the faces appeared unusually undisturbed, as if the contact zone had been stable over long time intervals without the burrowing, bioturbation, and slumping commonly seen at edges. Equally instructive and unsettling was what was not present. The area lacked the telltale indicators of strong bottom currents. Current meters deployed in the sector recorded long-term shear values well below thresholds that can carve sharp geomorphic features. There were no submarine flows powerful enough by the physics of the water column and the roughness of the sediment to have scoured a natural right-angled terrace from soft mud and rock. Mud volcanoes and diapirs, phenomena that sometimes produce abrupt relief, have characteristic dome-like or radial patterns. They do not yield clean 90-degree corners. Carbonate mounds can grow into pinnacles, but their faces are usually rounded and pocked. In some, the morphology contradicted the most plausible natural formation mechanisms that investigators knew. Geophysics supplied more ambiguity. The magnetometer sweep was noisy but did not indicate a large, coherent metallic mass under the feature. Instead, there were subtle, patchy anomalies, localized deviations in the magnetic gradient that could indicate either heterogeneous sediments with iron-rich pockets or a suite of materials with varying susceptibility. Gravimetric readings suggested a mass contrast lower than would be expected for a solid stone block of the feature's apparent dimensions. These readings did not conclusively rule out rock, but neither did they fit the neat equation geologists would expect. The inability to classify the object as rock probed between empirical discipline and speculative hunger. The safe inference, the one that most scientists initially adopted, was restraint, an anomalous geologic assembly, perhaps a unique interplay of tectonic faulting, mineral precipitation, or uncommon solidification processes. This explanation preserved the orderliness of Earth science. It left intact the operating assumptions about the planet's capacity to assemble strange things without agency. Yet the more the team interrogated the anomaly, the more subtle contradictions accumulated. The faces were unnaturally planar. The edges were too sharp given the known rates of sediment loading and the abrasive chemistry of the Hadal. The reflectivity pattern suggested surfaces that, at very fine scales, were smoother than natural fractured basalt typically is. The lack of strong currents meant a lack of erosive sculpting. If shape was not carved out, then it must have been constructed, or it must have formed under some process so unusual it deserved the new classification. In the hours that followed, conversations in the ship's conference room shifted from the vocabulary of acoustics into something that read like philosophy. Participants spoke in measured terms about Occam's razor and the perils of anthropocentric bias. Some reminded the group of how often instruments and data pipelines had produced illusions of pattern that evaporated under closer attention. Rope shadows mistaken for canyons, biological aggregations misclassified as hard substrate. Others leaned into the larger implications. A geometric object on the Hadal plane challenges presumptions about what can be preserved and what could be created in deep time. The trench had erased far more than it had kept. The more senior voices said, to see a geometry at this scale and depth was to confront the possibility that either an unusual, natural process had been found, or that the planetary archive sometimes preserved things in forms humans had not expected. Decision-making followed a scripted prudence. The immediate imperative was to validate, not to declare. A remotely operated vehicle, ROV, with high-resolution cameras, manipulators, and a suite of chemical sensors was earmarked for a reconnaissance dive. Teams prepared contamination protocols that had been sharpened after the earlier discoveries of modern debris, gloves of inert polymer, sample canisters protected with double seals, and strict chain of custody registers to prevent confusing modern tooling with ancient signals. The ROV's lights were tuned to minimize biological elicitation. Pumps were throttled to whisper rather than roar, in an effort to reduce the instrument's footprint on the local ecology. The moral calculus was already shifting. This was not merely a question of discovery, but an ethical negotiation with a fragile archive. The ROV descent became, in itself, a small ceremony. The vessel winch eased the cable as the craft slipped below layers of indifferent blue. Cameras came alive with the Hadal's peculiar darkness, ringed by the cold cone of artificial illumination. The first frame showed familiar terrace and soft mud plains, punctuated by pale, gelatinous life forms that had become known inhabitants of these remote slopes. Then the block appeared, slowly, as if the light had been granted only a narrow permission to reveal it. The initial close-up solidified the disquiet. The faces were plainer and broadly smooth. At the centimeter scale, the surface texture varied. Some patches bore a faint microtopography like fossilized brushstrokes. Other zones were mirror-sheened but covered in a thin, organic film that glinted faintly when light grazed it. Where the feature met the surrounding sediment, the contact was clean and tight. No talus apron, no collapsed rubble field, no obvious assemblage of ejected blocks. The ROV's manipulator extended one gloved finger to gently touch the face, and the contact produced only a whisper of resistance. The instrument recorded a slight flutter in the sediment around the contact point, and microscopic particulates settled like dust around the manipulator's tip. Those particles were sieved in situ, preserved in a sterile chamber, and later analyzed at sea. Spectrometry of the adhered film and of the thin particulate sheaths returned unexpected chemistry. The organic matrix resembled a complex polysaccharide web infused with iron oxides and microbial metabolites, the sort of biofilm that had been observed on deep-sea glass and man-made surfaces, a microbial wrapping that colonizes any exposed surface. The implication was clear in one direction. Whatever the material beneath, the environment had allowed living matter to make a living on it. But the underlying substrate resisted simple lithological assignment. The ROV's laser scanner produced a high-resolution topography. The faces were too straight, the corners too true, the planar continuity too persistent to be casually explainable. At the same time, an undercurrent of methodological caution circulated. The team knew the power of pareidolia, the brain's tendency to see familiar shapes and randomness. In high-pressure, low-illumination contexts, cognitive bias is a hazard. Instrumental signatures can mimic the geometry of straight lines when the signal-to-noise ratio is strained. The investigators therefore amplified skepticism with redundancy, triangulated the feature with different acoustic bands, repeated magnetometer passes, deployed independent sub-bottom chirp profilers, and sent the ROV back with a different sensor complement to gather comparative data. The deeper interrogation added layers to the mystery. Microchemical assays in the shipboard lab found isotopic ratios in the film and adjacent sediments that were subtly anomalous. Certain trace elements were concentrated in patterns inconsistent with detrital deposition from the water column, but consistent with localized precipitation or deliberate deposition. Small fragments recovered from the immediate lap of the feature contained crystalline structures atypical of surrounding basaltic dust. These were discrete, tiny anomalies, not the kind of smoking gun evidence that settles narratives. Still, their persistence across sampling protocols amplified the sense that the object had a materiality unlike its neighbors. Beyond materials, science, the discovery raised a more unsettling epistemic question. How would the planet's slow processes treat such an entity over millennia? The trench is not merely a place that erases, it is a place that rewrites. Biological colonization, mineralization, and sedimentation act like editors with different priorities. A manufactured object, if left undisturbed, would be repurposed into the biogeochemical cycles of the Hadal. Biofilms would cloak it. Mineral precipitates would mineralize films into stone-like crusts. Sediments would accrete in laminas that gradually recontextualize it as a natural outcrop. Discerning the object's origins, therefore, might rely on traces deep inside those rewritings, subtle isotopic signatures, microfabric anomalies, the presence of materials that do not occur in the known geochemical palette of the region. That realization produced a quiet, ethical debate among the team and, in extended conversations across disciplines, among external advisors. Some argued for restraint, to leave the object largely in situ, and to prioritize non-invasive, long-term monitoring. In their view, the trench's role as archivist could be both a protection and a source of confounding, unnecessary disturbance. Would risk altering an already delicate stratigraphic record. Others argued for targeted sampling, a small core into the object's flank, a microdrill to retrieve interior material, a retrieval of a representative flake for absolute dating. The tension was not merely procedural, it was ontological. What obligation did investigators owe to a potential object that might be an artifact and thus a vestige of past intelligence, versus a unique natural formation? Both camps held to a shared principle: uncertainty warranted humility. The public imagination, not surprisingly, began to pick at the discovery in ways that scientists found both invigorating and taxing. Popular framings leapt quickly from measured curiosity to narrative extremes. Speculative headlines promised either the vindication of lost civilizations or the arrival of alien constructs. Within the research community, the mood was different, calibrated by the slow scales on which the trench operated. The block's presence was a case study in a difficulty of reading deep time. A geometry at 11 kilometers down is not a confession but a fragment, and fragments can be deceptive. The proper response, the scientists agreed privately, was a program of patient, methodical work, not theatrical pronouncements. As equipment and planning matured into a staged campaign of study, the discovery began to look less like a plot twist and more like a long-term problem in epistemology. The object served as a lens through which to examine how human instruments and human narratives interact with planetary archives. It forced clearer questions. How do life and materiality recombine to re-encode artificiality into geology? What senses are required to separate weathered manufacture from peculiar mineral behavior? How does one ethically sample a feature whose disturbance might destroy the very clues needed to interpret it? The block remained, for the time being, an unresolved sentence on the seafloor. It rose 30 meters above the mud like a stubborn idea refusing to be subsumed into the planet's default narratives. The team increased the cadence of observation, establishing a grid of long-term acoustic and optical monitoring, deploying passive hydrophones to catch any biological activity peculiar to the structure, and leaving in place a series of dyes and reference beacons to calibrate future measurements. In the slow calculus of deep time, monitoring is an act of patience that concedes the limits of immediate explanation. Ultimately, the most durable lesson of the encounter was less about what the block might be, and more about how humans read the planet's record. The trench had offered a shape that refused easy classification, and that refusal forced humility. It reminded observers that the Earth's archives are not transparent repositories waiting to be decoded by will and desire. They are dynamic systems in which materiality, biology, and time conspire to accept, alter, and sometimes obliterate marks. A right angle on the seafloor is not a verdict. It is an invitation to learn new alphabets. In that invitation, the team found the proper posture, not to rush toward mythology, but to extend equipment and patience, to refine protocols, and to accept that some answers would arrive in the fall of months and years, rather than the flare of headlines. The trench, patient as ever, continued its long work. The block stood mute and inscrutable, a geometric question under pressure, and the only honest response was to listen, to the instruments, to the microbes that colonized its faces, and to the slow, necessary humbling that any serious study of deep time requires. What does it mean to find a breath in a place that is supposed to be still? The discovery was not a dramatic geyser or a volcanic blast. It arrived as the simplest of testimonials, a faint warmth on a thermal map and a whisper of gas on a mass spectrometer readout, and those two small deviations were enough to reroute years of method and metaphor. The trench, which had so often presented itself as patient and indifferent, offered something intimate, a place where chemistry was being rearranged in ways that did not fit the tidy categories of purely geological processes or the well-worn templates of hydrothermal venting. The instrument that first signed the anomaly was, in itself, unremarkable. A worn bed sensor array, designed to detect fractional changes in bottom temperature over time, had been left to collect baseline data as part of a grid monitoring program. Its duty was not to find drama, but to register patience, tenths and hundredths of degrees averaged across months. Late on a clear watch, the array's slow-moving graphs arrested technicians with a line that rose and did not unwind. The water around the package, virtually frozen by deep-sea standards, registered a persistent delta, a few degrees above ambient, centered on a patch of seafloor previously mapped as uniformly cold and inert. A thermal blip in the Hadal zone is at once tiny and enormous. It is tiny in absolute energy terms. It is enormous in implication. Heat, at those depths, dissipates into an oceanic background that rarely yields surprises. Even a broader human imagination, quick to picture black smokers and hot chimneys, must be corrected. The anomaly was not a smoking vent. It was diffuse and low in power, a warm breath that leaked from the skin of the earth like steam from a seam. The warm patch was not the only irregularity. When a remotely operated vehicle was dispatched under strict contamination protocols, its downward-pointing mass spectrometer and a network of gas traps recorded an escaping mixture of gases clustered within a spatially confined zone. Methane and hydrogen were the principal components, accompanied by traces of ethane and other light hydrocarbons. What unsettled the analytical team was less the identity of the gases than their character. Isotopic ratios and relative abundances that did not map simply onto classic biogenic methane or the textbook contours of serpentinization. Derived hydrogen. Methane in the oceans typically speaks in recognizable accents. Biogenic methane, produced by archaea digesting organic matter, tends to carry a light carbon signal depleted in carbon-13. Thermogenic methane, cracked from buried organic rocks by heat, often carries heavier isotopic signatures and associated higher hydrocarbons. Abiotic methane, produced by reactions like serpentinization or Fischer-Tropsch-type processes, bears a more complex isotopic fingerprint and may be accompanied by surprisingly high hydrogen. In this patch, the methane bore a middling carbon-13 signature. Hydrogen concentrations were elevated beyond expectations for simple organic decomposition, and the relative ratio of ethane to methane was higher than what would typically be expected from pure biogenic sources. Furthermore, noble gas admixtures and small anomalies in helium ratios hinted that something in the sub-sediment chemistry was not behaving according to the familiar script. Those laboratory details translated for many into an interpretive knot. The scientific reflex spun through possibilities. A slow, serpentinizing fracture beneath the sediments, diagenetic reactions liberating trapped gases from ancient organic layers, methanogenesis fueled by local clusters of chemosynthetic microbes, or, less comfortably, a reaction catalyzed by introduced metal, the corrosion and transformation of exotic materials buried in the mud. The trench had already taught restraint. Sediment as a patient confessor, it will reveal, but only in laminae and isotopic whispers. Yet the combination of mild heat and an unusual hydrogen-methane cocktail gave the impression of a system that was both chemical and social, chemistry arranged in ways that invited life. The life around the seep, when observed, responded like moths to a dim table lamp. Where the seep vented, the microbiology changed abruptly. A halo of filmy mats, pale and slick, radiated from the warm spot. Under magnification, these mats were not simple carpets of common bacteria, they were complex consortia. Biochemical factories organized along local gradients. Sulfur-oxidizing microbes glinted with sulfur globules. Ion-reducing consortia converted dissolved metals into distinct mineral precipitates. And hydrogenotrophic archaea, organisms that use hydrogen as a primary fuel, clustered where hydrogen partial pressures peaked. Small, translucent grazers aggregated at the margins, feeding on the profuse microbial bloom as a whale skeleton feeds a community. The Hadal's fauna, often spare and conservative, had formed a micro-ecosystem tailored to the peculiar feast on offer. Of particular interest was the way those organisms rearranged material. Microbial mats in the halo secreted exopolysaccharide films that trapped fine particles and bound metal ions. Where the mats thickened, the sediment's color changed. Light browns deepened to darker, iron-stained hues. The surface texture acquired a crustiness that resisted simple mechanical probing. In a few places, tiny, layered concretions formed, micro-aggregates whose chemistry was a hybrid of microbial secretion and mineral deposition. These were biological responses, but also geological acts, microbes altering the local geochemistry in ways that, given time, would harden to a new kind of lithology. Ah! The instruments documented these processes with a cold, meticulous eloquence. Microelectrodes plunged into the mats measured steep chemical gradients across millimeters, sharp declines in oxygen concentration, abrupt increases in sulfide and ferrous iron, and a tight zone where hydrogen pressures climbed. In situ incubations with labeled carbon compounds revealed active carbon fixation in the mats, indicating that chemosynthetic productivity in this warm halo rivaled expectations for low-temperature seep systems in other basins. Time-lapse photography, a slow cinematography of patient life, showed microbial fronts advancing and retreating with currents, and with transient changes in gas flux. Nothing in these images shouted an industrial origin, nothing spoke with the unambiguous syntax of artifacts. Still, certain metallic anomalies persisted. Sediment cores taken across the halo revealed elevated concentrations of metals. Iron and manganese were expected at hydrothermal and seep interfaces, but the cores showed localized enrichment of nickel, copper, and several rare earth elements in patterns that were spatially coincident with the gas emissions. More puzzlingly, fine metallic flakes, angular and reflective under microscope light, peppered certain laminae. Their mineralogy was not strictly igneous. X-ray diffraction and electron microscopy showed alloy-like microstructures with crystalline phases that hinted at processed metals rather than purely precipitated mineral phases. Some flakes bore corrosion textures reminiscent of prolonged exposure to seawater with layered oxides and pitted surfaces. Yet their microstructure was suggestive of manufacturing trace inclusions and grain boundaries that, on close inspection, did not map easily onto natural crystalline growth. The analytical result coerced the mind along two parallel paths. One was conservative and geological. Earth sometimes makes unusual alloys through complex redox and catalytic processes at depth. Mineral precipitation can form metallic aggregates with superficially manufactured textures. The other path was speculative. Metallic inclusions of this form could originate from introduced technogenic material, long since fragmented and corroded, now reworked by the trench's slow economy. In that possibility lay a troubling thought, not sensational in the cinematic sense, but genealogically destabilizing. That technological byproducts, or even vestiges of past industry, could be reincorporated into deep-sea geochemistry in ways that mimic natural processes. The research community's reaction, the diffuse, unnamed body of curiosity and dread that had become the project's emotional landscape, folded into the data. The shared feeling was not melodrama, it was a layered awareness, excitement at discovering a living geochemical artifice where hydrogen-fueled life and rare metals congregated, humility at the complexity of processes that blurred the line between natural and artificial, and a restrained unease about what such blurring implied for reading deep time. The trench had already shown that plastics and synthetic compounds could reach 11 kilometers down. Now, the more delicate question surfaced: could the planet, over geological spans, convert technogenic remains into mineral signatures that would persist as part of the rock record? If so, how should scientists read those signatures? Method followed worry. Sampling protocols were tightened. Instruments that once took single snapshots of composition were retooled for longitudinal interrogation. A benthic flux chamber was deployed to quantify the rate of gas emission and the flux of dissolved metals. It produced numbers that suggested episodic pulses rather than a steady vent. An autonomous microsampler siphoned small volumes of sediment, pore water at hour intervals. These devices were chosen for minimal disturbance. The trench had learned that heavy-handed sampling risked wiping away fragile contextual clues. Each step of analysis, from elemental mapping to isotopic fractionation, was accompanied by a mental ledger of alternate hypotheses. Abiotic geochemistry, microbially mediated mineralization, introduced metallic sludge degraded over centuries, or compositional mimicry produced by exotic mineral pathways. There was also a haunting temporal imagination attached to these observations. Metals concentrated in the sediment do not remain inert. Microbial communities can encapsulate and transform metals, producing mineral phases that may survive diagenesis and even subduction. Gas plumes alter sedimentary organics and leave isotopic breadcrumbs. A diffuse, low-temperature chemical system, repeatedly active over decades or centuries, can accumulate layers of alteration that become legible in cores as anomalies. Small islands of enriched elements like punctuation marks in the continuity of mud. For the person who thinks in deep time, these small islands become sentences in a geological text. The problem is interpretation. Who, in the distant future, will read those sentences and with what assumptions? Beyond the purely scientific, the seep's character revived moral reflections already living in the project's background. The presence of metals with ambiguous origins echoed the earlier discovery of plastic at depth. The planet preserves and repurposes. What humans cast away does not simply vanish. It is woven into the planet's slow fabric. In some cases, that weaving is visible and legible. In others, it becomes chemistry. The trench silently archives human action, often in forms that transform meaning. Even if the metallic flicks were natural, their co-occurrence with anthropogenic microdebris and with chemical signatures that resembled manufactured corrosion created a composite record of human and geochemical entanglement. The biological response to the gases also invited philosophical musing. Here was life that took advantage of what the Earth offered, whether that offer had a natural or artificial provenance. Hydrogen is a generous molecule in a world where energy is scarce. Organisms that could metabolize it gained a conspicuous advantage. They organized around that advantage. They made visible what had been invisible. In the Hadal, biological communities were interpreters. When they concentrated, when they built mats, when they precipitated minerals, they inscribed a living commentary on geochemistry. Their signatures might outlast the transient plume itself. Over centuries, the traces of their activity, biomineral crusts, altered isotopic fabrics, layered organics, could harden into a narrative legible to future readers. The fieldwork consolidated one primary epistemic lesson in the trench. The categories natural and technogenic deposit do not hold as neat partitions. They are instead overlapping spectra. Chemical signals mix. Microbial life rewrites mineral phases. Introduced materials are scavenged, corroded, and incorporated. The result is an archive that privileges process over provenance. What matters in the long run is not whether a molecule was made by human hands, but whether it altered the trajectories of matter and life. This ecological imprint is the kind of signature that endures in sediments, subtle, distributed, and often ambiguous. As the team withdrew its instruments to protect them from accelerated colonization, they left in place long-term sensor packages. The trench's patient calendar would be the judge. The warm patch might flicker out, the gas flux could dwindle, metals might be slowly sequestered into microbial concretions, or the system might become a persistent seep, a chemical oasis that would continue to attract life and to alter sediment chemistry for centuries. Each possibility carried different implications for how the planet's memory would be written. In the months that followed, analysts continued to parse the gas isotopes and metal microstructures, recalibrating models and expanding data sets. What remained constant was a sense of constrained astonishment that a modest warmth and a faint exhalation could reshape questions about preservation, about how life and chemistry co-produce signatures, and about the ethics of leaving traces in a world that reconfigures them on its own terms. The Hadal spoke in low-power pulses. It exhaled hydrogen and methane like a secret. The response of living systems, mats, microbes, grazers, mineral precipitates, translated that secret into a visible chorus. That chorus was not proof of anything grandiose. It did not reveal lost cities nor confirm the presence of artifacts. It did something perhaps more important. It forced a recalibration of how to read the planet's slow script. A mild thermal emission, a hydrogen-rich flux, an unusual ratio of light hydrocarbons, and the curious congregation of metals together produced a narrative that could be read in two stable ways, one conservative, one speculative, and both required patience. The trench, in offering a small breath from beneath its skin, had renewed a broader lesson of deep-time thinking. That preservation is an act of transformation. The human traces are often converted into geochemistry, and that the language of the earth is written in processes more than in objects. Thus the warm patch remained a kind of question mark on the map, not loud, not dramatic, but stubborn. It invited continued listening and a more capacious imagination. The Hadal, always patient, had reminded those who study it that the smallest deviations carried disproportionate weight across millennia. An unusual concentration of metal here, an anomalous gas there, in the ledger of the planet. Wah! Such entries may be marginal at first, but over long spans accumulate until they alter the narrative. The trench did not give its answers quickly. It offered, instead, a slow and necessary discipline, to observe with humility, to interpret with restraint, and to recognize that the Earth's archive writes in chemical grammar sometimes indistinguishable from authorship. What does agency look like when it is distributed, when no single head can be pointed at the world and no pair of eyes insists upon a focus? That question arrived like a ripple through the expedition's telemetry, not as a headline making reveal, but as a persistent puzzle tucked inside a stream of otherwise ordinary data. Cameras had recorded formations of life before. They had filmed schools, clouds of krill, columns of siphonophores, elegant swarms that moved as if a single mind were pulling invisible strings. What made this encounter different was the choreography and the reaction to light, a swarm that behaved like a fleet of drones, then, when illuminated, stopped in perfect lockstep and disappeared. The initial footage was unremarkable in the technical sense. A remotely operated vehicle, Rove, had traced a slow transect across a median slope of Hadal Plain. The machine's lights carved narrow cones into immeasurable dark. The video feed was a wash of muted grays and the pale, ghostly shapes of known deep fauna. Then, sliding into frame, came a band, not a loose aggregation, but an ordered column, of thousands of small, elongate bodies moving together with a precision that read like mechanical schooling. They flowed in tight formation along a sinuous route, each individual maintaining a fixed offset from its neighbors, turning in unison at pace, expanding and contracting the column without collision. The motion was not the jittery, diffusive ballet of plankton. It was orchestrated. Observers who watched the footage later described the sense of unnaturalness with an almost religious hush. The animals moved like a swarm of engineered drones, a suggestion that owed more to human technologies than it did to taxonomic categories. The ROV's forward lights, when briefly trained across the formation, produced a response that hardened the oddity into a phenomenon. As the cone of light swept, the whole aggregation arrested. Movement did not slow into disordered hesitation. It ceased in perfect synchrony. For a long, breath-held beat, the column held its shape like a frozen filament in water. Then, without fanning or thrashing, the formation dissolved. Individuals seemed to fold inward. The backscatter from sonar fell abruptly, and the column vanished into the seafloor, as if the living bodies had been absorbed by the mud itself. That disappearance was the moment that converted technical curiosity into epistemic disquiet. Instruments recorded it as a compound event. Optical frames showed the freeze, and then a thinning of visible biomass. High-frequency backscatter went from a distinct band to background noise in a matter of seconds. Turbidity sensors registered a micro-spike in suspended particles consistent with a concentrated collapse at the interface between life and sediment. Contact microphones on the ROV's manipulator picked up faint, regular micro-pulses during the freeze, not the chaotic clatter of a panic, but a patterned beat whose frequency matched the interval of the swarm's prior translational rhythm. Hydrophones picked up little or nothing. The event was not acoustic in the way a whale song would be, but it left faint mechanical signatures near the substrate. Describing such moments demands restraint, because human senses are eager to animate patterns with intentionality. The word drone is a shorthand that carries technological implication. A formally correct account must separate appearance from assertion. The recorded movement had a precision that could have arisen from biological mechanisms of coordination, chemical signaling, hydrodynamic coupling, mechanosensory feedback loops, without any need for electronic control. Yet the synchrony and the coordinated vanishing suggested a degree of collective integration that pushed the boundaries of what scientists had expected from Hadal assemblages, especially in an environment where energy is scarce and behaviors are typically conservative. The first analytical layer focused on morphology. Yeah! Frames were parsed in high resolution, and individual bodies extracted for study. When magnified, each unit was not a mini drone, but a soft, elongate organism, a sac-like body with slight undulations along its flank, membranous lobes that fluttered in microtime, and a trailing fringe of fine filaments. Nowhere did the imagery reveal structures akin to camera eyes, no iris, no pigmented ocelli, no raised sockets. Pigmentation seemed absent, coloration was uniformly pale or transparent. Lenses and optic nerves, if present, were not detectable at the camera's resolution. The lack of visual organs was not itself surprising given the abyssal darkness. What was surprising was how these organisms managed precise spatial keeping without apparent optical input. Laboratory follow-up expanded the mystery. Net towers and suction samplers returned hundreds of individuals, and under microscopes, the anatomy told a story of different sensory priorities. Dense arrays of mechanosensory cilia-covered flanks and trailing fringes, their orientation and cellular connectivity, suggesting the capacity to sense fine gradients of shear and pressure across the body surface. Specialized epidermal cells showed dense innervation and ring-like connective tissue that could propagate mechanical perturbations across several millimeters. There were also pockets of exuded mucus with embedded mineral grains, adhesive films that, when modeled in flow tanks, altered local hydrodynamics in ways that produced stable wakes and channels. In other words, the organisms carried the tools to read and rewrite the fluid environment around them. Genomic sequencing provided further clarity on sensory architecture and a hint at the communication modalities in play. The extracted DNA contained gene families associated with mechanotransduction, proteins that transduce pressure and shear into electrical signals, and with chemoperception, including an expanded array of receptor classes for dissolved organic compounds. Genes implicated in light detection were present in reduced or divergent forms, not matching canonical photoreceptor sequences found in surface taxa. Perhaps most intriguing were gene clusters suggestive of complex inter-individual signaling, multiple quorum-sensing pathways, secreted small peptides likely used for rapid chemical mediation, and, unusually, genes coding for extracellular polymeric substances, EPS, that could be deployed to form transient matrices. The genetic picture described organisms adapted to a tactile and chemical world. They read currents and tastes more readily than they read light. That explains, in part, how collective coordination could function in the absence of eyes. Mechanosensory arrays allow individuals to detect the movement of neighbors through subtle pressure waves. EPS matrices change local viscosity and can transmit movement passively. Models of hydrodynamic coupling showed that when adhesive filaments link members into a loose lattice, a single contraction can propagate like a wave of coordinated movement, steering the group. Thus, a swarm's apparent drone-like movement could be an emergent property, each organism locally following simple rules tied to shear and concentration, while the aggregate expresses complex, directed motion. But the question of disappearance remained. How did thousands of soft-bodied individuals vanish into mud that normally absorbs only slow rainfalls of detritus? The in-situ chemical tests and high-speed optical analysis suggested a mechanism that was less disappearing than reconfiguration. When exposed to directed light, not particularly intense in the broader sense, EBA, but different in spectrum from the ambient bioluminescent background, the organisms curtailed motility and secreted a dense EPS. That secretion dramatically increased the local density of suspended materials, binding individuals together and with the sediment. The effect was to change the collective's buoyancy and frictional coupling with the substrate. A sheet of mucus laden with mineral particles could collapse into the interstices of the mud surface and become acoustically invisible. Backscatter dropped because the acoustic impedance of the composite matrix matched that of surrounding sediments more closely. Dan did the organisms alone. In other words, the disappearance was not erasure, but a rapid camouflaging or embedding into the seafloor facilitated by manufactured secretions and hydrodynamic magic. Even with a plausible biophysical mechanism, the response to light remained suggestive. Why would a non-visual organism respond so precisely to photons? The answer, it seemed, was behavioral economy. Photons are rare currency in the Hadal. For an organism that has lost image-forming eyes, the detection of sudden photon flux might nevertheless be significant. A brief flash in an environment otherwise resonant with bioluminescent flicker could indicate the passage of a large stimulus. The approach of a predator, the sweep of a probing instrument, or the clumsy intrusion of a machine. Freezing and collapsing into the substrate, then, is a conservative tactic. Reduce conspicuity, minimize energetic exposure, and allow the environment's sedimentary camouflage to reclaim the group. The group's secretions, evolved perhaps for attachment or for trapping particulate food, were repurposed into a fast-acting concealment net. This interpretation, plausible on its face, did not remove the unease of the footage. The ROV's bright cone had been a human tool of observation. The swarm's reaction rendered that tool ineffective and underscored an older point. Observation is always an intervention. The expedition's lights instructed, the creatures answered, and the result reconfigured what could be seen. It was a sharp reminder that instruments do not simply record, they nudge ecosystems into behaviors that can distort the very phenomena they were designed to witness. The encounter also reanimated a familiar intellectual knot. Where does one draw the line between the biological and the artificial when collectives exhibit mechanical precision? Human language, apt to anthropomorphize, may call such behavior robotic because it resembles engineered systems. But in the Hadal, similar constraints, energy sparseness, narrow morphospace, and the premium on efficient movement can produce convergent solutions. Swarm behavior is a strategy. Its expression may converge on patterns humans have chosen to emulate in autonomous vehicles and distributed robotics. The resemblance is not evidence of manufacture. It is a testimony to the economy of physics and evolution. That said, the resemblance forces a practical question for detection. A distant observer, unfamiliar with the diversity of plausible biological swarms, might misinterpret such organized motility as proof of engineered artifacts. The scientific team reframed the episode as an object lesson for how the planet's long record could be read or misread. If 1,000,000 individuals, repeated over centuries, leave no hard parts and retreat into sedimentary matrices when illuminated, what traces would remain for future geologists? The secreted EPS, mineral-laden, could form resistant laminae that record episodic collapses. Chemically altered layers, richer in refractory organic complexes and in metals sequestered by microbial activity, could look at a distance like unusual depositional events. Civilizations searching for hard artifacts might pass over such signatures entirely. The Hadal archive, it turned out, often writes in soft conditions that leave ambiguous residues. Emotionally, the encounter invoked a spectrum. There was wonder at the ingenuity of life that could maintain such tight coordination without sight, at the intricate coupling of behavior and physics visible in the footage. There was also a creeping humility, an awareness of how impoverished human sensory priorities can be in the face of other life solutions. And beneath both, a quiet anxiety lodged. If behavior can be so effective, a mode of presence that it eludes conventional detection, then whole histories might be invisible to archaeologies fixated on durable artifacts. The teams responded methodically. Protocols for observation were revised to include quiet, low-photon imaging, and to test stimuli with a palette closer to ambient bioluminescent spectra. Subsampling strategies emphasized non-destructive flow modeling and in-situ chemical tagging rather than net hauls that might disrupt ephemeral communal architectures. Long-term monitoring arrays were deployed to observe the same corridor across tidal cycles and seasons, checking whether the formations were migratory highways, seasonal gatherings, or persistent social structures. The longer view introduced further complexity. Whoa! Time-lapse observations over months revealed recurring traffic corridors, routes along which the swarms returned reliably, sometimes aligning with gradients of particulate flux or with the meanders of subtle benthic currents. In other seasons, the swarm shrank and dispersed, suggesting population dynamics tied to episodic rains of carrion or to geochemical pulses. The behaviors were not artifacts of provocation alone. They were practices embedded in an ecology, economies of movement, memory systems coded in repeating routes, and collective strategies for sensing a world that privileged pressure and chemical gradients. Philosophically, the encounter prompted reflection about what it means to be perceptible to a planet writing in deep time. The swarm's ability to become materially indistinguishable from sediment was a living analog to the Trench's earlier roles as both eraser and archivist. It underscored an unsettling possibility. That persistence in the geological record does not always favor solidity and spectacle. Sometimes it favors subtlety and process. A civilization's passing, or a species' practice, might be transmuted into patterns of laminae, into microscale chemical anomalies, into the mineralized residues of secreted polymers. For those who read the planet's margins, the lesson was urgent. Attention must be broadened beyond stone to embrace soft architectures and ephemeral behaviors that nevertheless leave durable marks. In the end, the swarm was neither triumph nor omen. It was an instructive instance of life assembling effective, non-visual strategies in conditions of brutal constraint. It was also a reminder that human tools of seeing, lights, cameras, sonar, reshape what they are meant to reveal. The Hadal's organisms had evolved a language of touch and taste and of shared mechanical coupling that allowed them to move as a single instrument of survival. When human lights intruded, the swarm answered with a behavior that masked rather than confronted. The disappearance was not a vanishing into fiction. It was a tactical retreat, a conversion of collective motion into embedded presence. The footage, the samples, and the months of subsequent monitoring accrued into a new chapter in the expedition's ledger. It broadened the speculative palette. If the planet can assemble entities that behave like machines without being machines, then the interpretive burden on future readers of deep time is heavier. Recognition will require not only instruments capable of fixing hard objects, but also attentions that can hear the grammar of shear, taste the code of chemicals, and map the slow traces of soft matter. The Hadal teaches that agency can be distributed, that endurance can be written in ephemeral polymers, and that to know the Earth's history is to learn a multitude of alphabets, some written in stone, others whispering through mud. What could live where light never arrives, where pressure is a sculptor and time is the medium? That question sits at the hinge of everything learned so far about the Hadal, and it insists on two uneasy possibilities. Either the life at the bottom evolved there, against constraints that would seem to preclude complexity, and did so with a subtlety that outstrips ordinary imagination, or the abyss is home to something older than recorded history, a continuity of biological practice so different in rhythm and scale that the human mind struggles to name it. Both possibilities are humbling. Both demand that thinking about life be remade in the language of deep time. To begin, it helps to reframe what complexity means, in a place defined by scarcity. On the sunlit shelf, complexity is often read through familiar markers, eyes, skeletons, muscles, behaviors tied to quick energy gains and losses. In the Hadal, such markers are expensive. Energy arrives seldom, and in small parcels, selection favors anything that stretches a calorie into a decade. Yet scarcity is an engine as much as it is a restraint. In places where a steady trickle of chemosynthetic energy or the occasional banquet of a falling whale carcass is reliably available, evolution will not stall, it will invent economy. The degree of complexity observed in Hadal ecosystems is therefore not surprising in the blunt sense of improbability. It is legible as an adaptation to a long, patient environment. Consider the engineering of metabolism. In shallow oceans, sunlight powers a vast, immediate web of productivity. Down here, the currency is chemical gradient and time. Life adapts by optimizing for low flux, high efficiency energy capture, enzymes that work at near freezing temperatures and under crushing pressure, membranes composed of lipids whose saturation and cross-linking resist deformation, proteomes that trade speed for durability. Those are biochemical strategies rather than flamboyant morphologies. They are, nonetheless, complex outcomes. Networks of proteins and genes co-evolve to solve constraints that are both physical, chemical, and ecological. Complexity, then, can be architectural rather than ostentatious. It is the sophisticated choreography of molecules, hydrogenotrophy here, sulfur oxidation there, integrated across layers of microbes, archaea, and multinucleate hosts. But beyond molecules, complexity shows up in social and organizational forms. Symbiosis becomes a primary route to innovation. Where single organisms cannot afford the metabolic cost of a full suite of functions, partnerships evolve. A large, gelatinous host can house dense microbial factories that convert hydrogen or reduced iron into organic carbon, while the host provides motility or position in a gradient. These nested communities can behave like organs, a mosaic of metabolic specialization that functions as a larger whole. Aggregations of individuals, the patrols, the cohesive swarms, can act as superorganisms, coordinating via chemical plumes, mechanosensory coupling, or extracellular matrices. Collective complexity in the Hadal is often distributed. Intelligence, if it is the right word, is not in a centralized brain, but in patterns of interaction that persist across space and time. There is also the question of evolutionary time. The Hadal is an environment of extraordinary continuity. For millions of years, trenches have offered refugia, places shielded from surface cataclysms, where the geological conveyor belt can both erase and incubate. Isolation matters. Long-term isolation, combined with stable selective regimes, provides a crucible in which novelty can arise gradually and be retained. Lineages that diverge under the trench's regimes accumulate differences not only in genes but in developmental rules, in life history pacing, in the very ways they parse environmental information. Genetic divergence in Hadal taxa often points to ancient splits, millions of years of separate history, not recent novelties. In evolutionary terms, the trench behaves like an archive of lineages that have been permitted the time to explore morphological and biochemical pathways unavailable in more changeable habitats. Yet this evolutionary account, though plausible, leaves a cognitive itch. How could such elegant adaptations arise in an environment so punishing? The answer requires resisting the image of slow, blind tinkering as a blind alley. Evolution in the Hadal is not a random walk. It is guided strongly by energetic strictures. Natural selection, working across vast numbers of generations and subtle trade-offs. Craft solutions that look improbably polished to a mind accustomed to visible spectacle. The result is organisms whose complexity is in their integration, metabolic, structural, communal, rather than in muscular drama. A membrane that avoids collapse under pressure, or a protein fold that resists deformation, is as much engineering as the rib cage of a whale. It is simply an engineering problem measured in microvolts and angstroms. There is, however, a second set of scenarios that cannot be fully excluded, and that the trench compels us to entertain. The Hadal's stability and its function as a sink, a place where material accumulates, where the planet silently folds itself, open the door to the possibility of continuity of a different kind, relic biospheres, organisms or assemblages that predate known histories and whose persistence owes less to recent adaptation than to survival through cataclysms. The Mariana and other trenches have been witness to repeated mass extinctions, continental rearrangements, climate swings. Yet in these dark refuges, pockets of life might have endured, evolving on their own trajectories while the surface world rewrote human stories again and again. What would it mean for something to be older than history? In the Hadal, it does not require invoking intelligence in the sense humans imagine. What it does suggest is the existence of lineages or ecological practices whose genealogies reach into epochs before human memory. Organisms whose core biochemical toolkits are ancestral to much of what surrounds them, or communities that have persisted as coherent economic units across tens of millions of years. Genetic studies occasionally hint at such deep splits. Clades whose molecular clocks place divergence events near major planetary reorganizations. If the trench holds relict species, their biology may carry signatures of ancient Earth chemistry, metabolic pathways tuned to conditions that have otherwise vanished from the planet's shallower shells. But the possibility invites an even stranger thought. Could the Hadal harbor ecological intelligences whose persistence is not written in durable artifacts but in enduring practices? A sustained behavioral tradition, repeated migration routes, communal constructions, sustained biochemical engineering of a microenvironment might leave traces that are not stone monuments but layered chemistries, patterned sediments, and microbial consortia inherited across generations. In such a case, home is less a structure and more a continuously enacted niche, a set of practices that reshapes local chemistry and thus persists in the sedimentary record. Those signatures would be subtle, inscrutable to an archaeology that looks for masonry and metal. They would be detectable only by a kind of reverse engineering of process, noticing repeated isotopic anomalies, patterns of mineralization co-located with biological mats, rhythmic sediment laminations that correlate with recurring biological events. The Hadal's habit of transforming what enters it complicates this further. Modern detritus, plastics, metallic fragments has already been shown to persist and be incorporated into biological and mineral cycles. Over millennia, synthetic molecules can be transmuted by microbial activity into mineralized accretions. Metal flakes can be encrusted and recrystallized, and polymers can be bound into organo-mineral complexes. The planet's chemistry makes no categorical distinction between natural and artificial. It reworks and repurposes. That means a past presence, whether biological or technological, could be rewritten into the language of geology. What were once constructed forms might be rendered into isotopic quirks, layers of altered sediment, and microbial communities that encode the memory of something no longer visually legible. This raises methodological consequences. The tools used to hunt for proof of the ancient, cameras, magnetometers, visual surveys, privilege a particular ontology. That durable shapes matter most, but the Trench has repeatedly taught that preservation can be chemical and behavioral. Detecting complexity that evolved in darkness therefore demands different instruments and different attentions. It requires geochemical forensics, compound-specific isotope studies, layered microfabric analyses, long-term monitoring of gas fluxes and trace metals, deep metagenomic sequencing that can reveal ancient gene flow and unusual metabolic architectures. It requires listening to rhythm and repetition as much as looking for a shape. The Hadal archive is written in processes as well as in objects. If the deep is a place where relic life might persist, then the origin and maintenance of complexity there also invites rethinking of what counts as intelligence or cultural continuity. Distributed cognition, systems in which information and memory are not stored centrally but embedded in living mats, in biofilms, in sedimentary patterns, becomes a plausible category. A biofilm that maintains a chemical gradient year after year, mediated by generational continuity of microbial consortia, is a form of environmental engineering. Over geological spans, such engineering can shift local mineralogy, alter sediment compaction, and leave a trace in the rock record. That is not civilization in human terms, but it is continuity of practice, a lineage of living processes that maintain and reproduce a niche in ways that have persistence beyond individual lifespans. The ethical and psychological implications of these possibilities are significant. They force a posture of humility. The Trench, patient and indifferent, demands slow work and a readiness to be surprised. The discovery of complex behaviors, coordinated swarms that vanish into the mud, mucus films that micro-move instruments, microbial mat communities that precipitate metals, admonishes the modern tendency to equate visibility with significance. It also reframes stewardship. If the deep archive human traces and, simultaneously, harbors biologies that are ancient and fragile, then human actions, plastics, noise, chemical runoff, are not simply local pollution. They become inscriptions into planetary memory, possibly altering the course of living practices that have persisted for eons. Speculation about home in the Trench should also be tempered by epistemic caution. Extraordinary claims require extraordinary evidence, and Hadal's complicating mechanics mean that interpretative error is easy. Mineral precipitation can mimic manufactured textures. Collective biological behaviors can resemble engineered systems, isotopic. Anomalies can derive from unexpected geochemical pathways. The honest posture for a scientist and for an orator of these deep events is to hold possibilities in tension, to treat evolutionary adaptation and deep continuity not as mutually exclusive, but as complementary explanations that often overlap in messy, revealing ways. In practical terms, the way forward is both technical and imaginative. Technically, it asks for integrated, multi-decadal programs, long baseline monitoring, repeated high-resolution sampling under contamination, avoiding protocols, and a suite of cross-disciplinary analyses that tie genomics to geochemistry to acoustics. Imaginatively, it asks for humility in hypothesis, a willingness to accept that intelligence, continuity, and complexity might not conform to human intuitions of tool-making or monument building. It calls for a broadened definition of legacy, one that includes biochemical signatures and pattern behaviors as potential entries in the planet's ledger. Ultimately, the deeper question is not simply what lives in the dark, but what counts as life, memory, and home when the timescale stretches beyond the human. The Hadal reminds observers that the Earth's architecture of persistence is plural. Some things endure because they are physically robust, others because they are repeatedly practiced, and still others because they are re-encoded by the restless chemistry of the planet. Whether the deep hosts organisms of startling complexity evolved over millions of patient generations, or relic practices that predate human history, or some blend of both, the consequence is the same. It forces a reorientation of curiosity toward listening longer, measuring more diversely, and imagining broader alphabets of persistence. The Trench's darkness is not an absence so much as a different medium for life's theater. It is both crucible and conservatory, eraser and archivist. It preserves, it transmutes, and it invites a new humility about human narratives of continuity. The question of who or what calls the Hadal home is therefore not merely a taxonomic puzzle, it is an existential prompt. It asks humanity to consider that history can be written in ways that are not immediately spectacular, in a membrane's chemistry, in a microbial mat's mineral layers, in the repeated sweep of a swarm that knows its corridor as a body knows its pulse. To study the trench is to learn new grammars for life and memory, and to accept that some of the deepest answers will arrive not as revelations, but as slow accumulations of evidence and wonder. What if extinction is not an absolute erasure, but a slow, patient pageant of survival, an accumulation of residues, lineages, and practices that persist not in the obvious monuments of stone and metal, but in the quiet choreography of chemistry and habit? This is the hypothesis that begins to take shape when one stops treating the Mariana Trench as merely a place of extremes and, instead, imagines it as a continuity machine, a cold, pressurized conservatory where evolutionary experiments have been allowed to proceed slowly and undisturbed, for intervals that dwarf human timelines. The trench, in that view, is less a graveyard than a living museum, a place where forms and modes of life that vanished from sunlit ecosystems could have continued, undetected, reworking their niche in rhythms that do not register in a single human lifetime. The intellectual arrest of this idea is immediate. Human thinking tends to imagine extinction as a categorical event. A curve of population declines to zero, and the record ends. But the planet's processes are not so tidy. Cataclysms that strip biodiversity from exposed continental shelves, asteroid impacts, global glaciations, massive volcanism, have asymmetric effects across environments, sheltered, chemically driven ecologies where energy flows are chemical rather than photic, are buffered against surface shocks in ways that matter. The Hadal realm is, by its very nature, isolated. The pressures that crush and the cold that preserves create a continuity of niche conditions where selective regimes shift slowly. For organisms adapted to those regimes, the world above can convulse and change without necessarily sweeping them away. Over geological time, this yields a possibility both simple and profound. That clades of life with origins ancient in the planet's history might have continued their trajectories in the dark, their genetic archives accumulating variation separate from the forests and reefs that dominate human imagination. Evidence nudges this hypothesis into plausibility rather than leaving it as mere fantasy. Genetic studies of deep-sea taxa, where available, often reveal deep divergences, molecular clocks that place splits and lineages tens of millions of years before their nearest shallow-water relatives. The organisms recovered from Hadal sampling seldom fit neatly into the taxonomic constructs borrowed from coastal biology. Instead, their genomes are mosaics, gene families repurposed for low-energy metabolisms, enzymatic systems that operate at extremes of pressure and ionic strength, and a proliferation of symbiotic modules in which microbes shoulder much of the energetic burden. If life in the Hadal is ancient, it is ancient in a way that is not inert. It is alive in the sense of being an ongoing experiment, one that has accumulated unique solutions to the physics of a rarefied world. The idea of the trench as a living museum is not to be taken as metaphor alone. The phrase describes a literal set of conditions that lend themselves to preservation of continuity. Slow sedimentation rates, cold temperatures that retard biochemical decay, and the general paucity of physical disturbance create pockets where interactions, biological, chemical, and geological, proceed as layered palimpsests. An organism that persists in such a pocket over many generations will leave traces, a characteristic microbiome, a set of stable metabolic signatures and local sediments, repeated micromorphologies where its feeding or locomotory habits alter the grain fabric. Over time, these become the museum's exhibits, not polished relics but living installations. Mats of microbes that continue to sequester metals and patterns distinct from surrounding beds, gelatinous hosts whose tissues entomb mineral grains in unique matrices, corridors of repeated passage where the microtopography holds the memory of generations. To imagine prehistoric life persisting in such a place is to reconfigure what counts as fossil and record. Traditional paleontology has privileged durable parts, shells, bones, hard mineral skeletons that survive burial and diagenesis. But the Hadal's assemblages teach a different lesson, that endurance can be achieved through other means. Repeated behaviors, seasonal migrations along the same trench corridor, habitual precipitation of certain mineral phases by microbial consortia, the persistent secretion of extracellular polymeric substances that accrete into laminae write continuity into sediments, without producing obvious macroscopic artifacts. The signature of continuity becomes chemical and structural at micro and nanoscales. Distinct isotopic ratios of carbon and sulfur locked into laminae, unusual haploid-like lipids and sedimentary organics, recurrent patterns of bioturbation that shape lamination sequences. A museum exhibit in the Mariana could be a layer that, when analyzed with the right instruments, tells of a practice performed constantly for a duration measured in millennia rather than a monument visible to the eye. There is a further twist. Isolation itself fosters both conservatism and novelty. In sheltered niches, selection can favor conservative retention of effective strategies, turning lineages into living time capsules. But isolation also permits accumulation of idiosyncratic innovations, developmental rules, and metabolic pathways that would be eliminated in more variable environments. The Hadal organism that thrives by metabolizing a specific complex of metals, or that uses mechanical coupling to move through the mud as a collective, is not merely adapting, it is carving out an evolutionary niche that may have no analog in the surface world. These pathways can become deeply integrated into lineages, producing organisms that are not simply old versions of shallow water ancestors, but are genuinely unique results of an evolutionary path shaped by pressure, darkness, and chemical economies. That uniqueness complicates detection. Much of the project's anxiety and wonder in earlier explorations came from the difficulty of interpreting absence. The trench does not present its history with the clarity of an archaeological site. Instead, it offers fragments that must be assembled by inference. If the ancient continued in forms that are mostly soft-bodied and chemically integrated into sediments, then conventional searches for relic artifacts or monument structures are liable to miss them entirely. In practical terms, the search for prehistoric life in the Hadal requires instruments and interpretive frames that privilege molecules, sequences, and sediment microstructures over macroscopic forms. Compound-specific isotope analyses, deep metagenomic reconstructions, lipid biomarker identification, and careful microfabric analysis of core laminae become the primary tools of a new archaeology, one that reads the planets' chemistry as its text. The possibility that the Mariana could harbor life older than surface narratives also raises a philosophical and ethical dimension. The trench becomes a kind of living archive whose steward is not human. For millions of years, organisms in the Hadal have been performing the slow work of existence with little benefit from human attention. To descend with lights and manipulators is to intrude upon that archive. The consequences of intrusion are not merely academic. The introduction of heat, noise, plastics, and reactive metals, by accident or design, can alter the delicate balances that sustain these communities. The project's earlier documented instances: plastic fragments at 11 kilometers, mucus films incorporating synthetic filaments, acoustic intrusions recorded as disturbances, are cautionary notes. If the Hadal indeed holds relic life, modern humanity's footprint might be inscribing itself into the same museum, altering the exhibits irreversibly. Scientists, in the face of such possibility, experience a complex affective register. There is awe, of course, the sense of encountering continuities older and stranger than imagined. But awe is often joined by unease and by a kind of guilty tenderness. Researchers feel the thrill of discovery and simultaneously the responsibility to protect. The impulse to sample and dissect, to bring fragments to the light for analysis, is tempered by an awareness that sampling is a form of disturbance. The ethical calculus becomes acute: how much to extract in order to know, and how much to leave to the patient work of the trench itself. These are not abstract dilemmas. They are design constraints on research programs that must reconcile the thirst for data with the need to preserve context that may be irreplaceable. Methodologically, the hypothesis that prehistoric life persists demands new rigor. Protocols must be built around minimal disturbance and maximal inference, sacrificial sampling only where critical, in situ analyses whenever possible, and layered redundancy to exclude contamination, sterile coring with pre-cleaned casings, in situ sequencing tents that limit exposure, and long-term observatories that collect acoustic and chemical data over decades instead of hours, all become essential. Likewise, interpretive work must be probabilistic and humble. A chemical anomaly in a core is not by itself a signature of ancient practice. It is a clue that must be integrated with biological, sedimentological, and contextual data. The patience of the trench requires patience in science to let patterns emerge across years of observation rather than pronouncing narratives on the basis of a single remarkable find. There is also an important historiographic shift embedded in this hypothesis. To imagine relic life living on in the Hadal is to decenter human narratives of continuity. Human civilizations inscribe themselves in durable forms and leave archives that are relatively straightforward to read. But life writ large does not require monuments to be continuous. A lineage that persists through mass extinctions by residing in chemical refugia is as continuous as any empire. Recognizing that fact reframes the human sense of uniqueness and permanence. The Trench, as a living museum, insists on a modest posture. Humanity's stories are recent and contingent, and the planet's longer biographies persist in subtle, durable ways that are often invisible to our eyes. This has consequences for how human societies plan for the future. If the Hadal preserves ancient lineages, and if modern waste and noise can alter those communities, then stewardship must be framed in deep time. Policies governing deep-sea mining, waste disposal, waste, and acoustic disturbance are not merely matters of resource use, they are acts of inscription. The isotopic and molecular traces humans leave will be legible long after political borders have dissolved. Plastics buried in deep sediments, metals corroded and reworked into mineral assemblages, and altered microbial communities will be part of the planet's archive. If there are already living museums in the Trench, then humanity's interventions risk rewriting the exhibits before they can be properly read. The speculative edge of this hypothesis is narrow but unavoidable to consider. What are some behaviors and practices that could be interpreted as cultural persistence are present in Hadal communities? One should avoid grand claims here. The evidence for culture in non-human animals, especially in deep-sea taxa, is tricky and must be approached carefully. Yet there are analogues that merit attention. Recurrent migration corridors, habitual modification of microhabitats, and multi-generational maintenance of microbial consortia that engineer local chemistry all amount to sustained practices. They are not culture in the human sense of symbolic artifacts and language, but they are organized continuities of behavior that can reshape material landscapes. Over geological time, they become part of the rock record. To call the Trench a living museum is in part to acknowledge these embodied practices not as human-like culture, but as persistent, meaningful arrangements of life that deserve to be studied and protected. Finally, the hypothesis invites a different kind of humility in scientific storytelling. The narrative that the Trench may shelter ancient life does not function as a clickbait revelation. It is a slow, patient argument composed of many small, accumulating observations, unexpected genetic splits, odd mineral assemblages influenced by microbial action, behavior that evade optical detection, and the presence of modern detritus already altering sediments. Each piece is partial. Together they form a lattice of possibility that is rich and compelling, but not decisive. The right posture for telling this story, whether in a laboratory, a policy forum, or a documentary voiceover, is one of cautious wonder. To speak of the Mariana as a living museum is to invite audiences into a different temporal scale, one where survival is measured in epochs and where continuity is recorded in laminae and lipid remnants rather than in stones and statues. In that sense, the Trench becomes a teacher. It lessens the human imagination to look for persistence in unexpected places, in the chemistry of mud, in the genomes of strange organisms, in the acoustic rhythms of a silent world, and in the slow accretion of behaviors into sedimentary habit. The hypothesis that prehistoric life has not been entirely erased by surface cataclysms is not a tidy answer so much as a recalibration of questions. It asks humanity to expand the tools of detection, to deepen the time scale of stewardship, and to accept that on a planet measured in hundreds of millions of years, endurance often wears the guise of the unremarkable. If that recalibration holds any truth, then the Mariana is more than a trench. It is a living exhibit whose catalogue is written in molecular whispers. To stand at its lip, even in thought, is to confront a different metric of time and value. The planet's memory is not a ledger of spectacular monuments, but a layered archive of practices, the repeated secretions of microbial mats, the persistent migratory corridors of soft-bodied swarms, the slow mineralization of surfaces colonized by life. These are the artifacts that endure, and if prehistoric life lingers, then humanity's privilege is to recognize those traces. Read them with patience and, where possible, preserve the museum so that its exhibits can teach not only scientists but the civilization that still believes permanence is always visible. What does it mean when silence is not absence but possession, a held thing curated and guarded? That is the question that arrived quietly in the trajectory of the Mariana Project. Not the silence of empty water, but the peculiar hush that falls when information is treated as a resource to be priced, partitioned, and postponed. In the trenches of bureaucracy, as much as in the trenches of mud, data was no longer simply evidence. It had become currency. The discovery that some measurements, images, and core samples were never placed on open tables but instead filed under access protocols, classified under origin stories, or locked behind private contracts reframed the scientific enterprise. The ocean's deepest dark had acquired a second human-made darkness, the blank space of withheld knowledge. The first hints were procedural and prosaic. Publication schedules slipped with polite inevitability. Peer review timelines stretched in ways that exceeded the usual delays of careful science. Footage released to the public bore timestamps and color corrections that downplayed anomalies. Press releases emphasized biodiversity and complex chemistry and neglected the chemical oddities and geometric irregularities that had animated late-night debates in laboratories. At the same time, notices of proprietary interest arrived from corporate partners, with legalese promising investment in future technologies should novel chemistries or materials be proven. Government agencies requested embargoes, citing national strategic interests and ongoing assessments. The requests were framed as trade-offs between public understanding and public safety. They were rarely outright prohibitions. The language was carefully calibrating, not censorship, but stewardship. Stewardship can be a euphemism. Where it slid into control, the mechanics were familiar. Non-disclosure agreements traveled with grant awards. Memoranda of understanding specified custody of physical samples, some cores retained by the state, some aliquots held by contracting firms that had financed the dives. Algorithms used to process sonar returns and image reconstructions were proprietary, obscuring the pipelines that translated raw pings into the clean lines of an interpreted map. In some laboratories, datasets were labeled sensitive and archived behind credentials. Requests from outside researchers were routed through formal channels that, for many applicants, turned into years-long waits or polite refusals. The scientific community, which ordinarily functions by replication and critique, found itself negotiating corridors of access that felt more like negotiation with insurers and counsel than with fellow investigators. Why would any institution seek to hoard observations of life adapted to crushing pressure, of methane hydrogen plumes, of geometric anomalies on the seafloor? The plausible motives were not all sinister, but they accumulated into a pattern that unsettled trust. One thread was resource control. If the Hadal hides chemistry is unusual enough to suggest novel catalysts, rare mineral concentrations, or unique microbial metabolisms that process metals differently, there is enormous economic value. From new battery chemistries to bioremediation pathways to mining prospects, corporations with deep pockets and expeditionary capabilities can convert a scientific lead into proprietary exploration, claiming intellectual property over experimental processes and, by extension, over tangible samples. Governments, too, might see strategic endowments in such discoveries. The interplay of economics and geology suddenly looked like geopolitics, strategic resources, future supply chains, technological advantage. Another motive had to do with social stability, evidence that suggested a continuity of biological complexity independent of human histories that the trench might harbor. Consequences, rewriting anthropology's assumptions, could unsettle narratives on which cultures draw identity. Official spokespeople argued that early, unmediated release of ambiguous signals could spawn panic, myth, or outright misinterpretation. In that framing, postponement was protection, a measured, calibrated disclosure that allowed time for contextual analysis before public consumption. The logic is understandable in a world where misinformation travels faster than careful translation, but it also provides cover for information to be reshaped. Legalities offered another avenue for withholding. Samples transported across international boundaries could be subjected to export controls. Contracts with private operators often included clauses that permitted firms to control sample distribution for specified periods. To recoup investment, even academic institutions reliant on competitive funding found themselves constrained. A lab that accepts industry money may sign agreements that grant first access to arising patents. The consolidation of exploration capacity into ever fewer hands. Private deep-sea firms, nationally funded research fleets, joint ventures made this tension structural rather than incidental. The consequences of that structure were more than procedural. Within the scientific collective, a peculiar emotional ecology developed. There was first indignation, the scholarly ethic that held transparency as a core value chafed against legal silos. There was also anxiety, Junior scientists whose careers depend on publications felt pressure to align with funders' timetables, to delay release, to sanitize captions. There was grief as well, a quiet mourning for the ideal that discovery should be a shared expansion of human knowledge rather than a negotiation over ownership. In public, these feelings crystallized into suspicion. Once the public noticed a pattern of redactions and selective releases, narratives of cover-up and conspiracy proliferated faster than the sober policy memos defending restraint. The question that followed, did they discover something the public should not know, is not reducible to a simple yes or no. It is, instead, a question that opens onto multiple nested possibilities, each dangerous in its own way. One possibility is mundane. The withheld data consisted of ambiguous anomalies that could be misread, and the delay provided time to replicate measurements and confirm methodological soundness. That is the conservative account, and often the true one. Science proceeds cautiously because mistakes are expensive and reputations fragile. But another possibility is more disquieting. The data hinted at patterns that would challenge core human narratives, an isotopic signature inconsistent with known prehistory, material microstructures suggestive of refined metallurgy predating recorded metallurgy, or structured acoustic sequences that, when stripped of noise, seem to display regularities at a level unaccounted for by current models. A third possibility married the technological with the political. Suppose a dataset suggested that human-made materials, or the energetic fingerprint of a technologically complex process, had been present in geological contexts previously thought impossible. That would be a revelation with cascading implications, claims about past human activity, about the timescales of industrial signatures, about the nature of preservation. It would touch on resource claims, on legal rights to seabed exploitation, and potentially on national security if a material signature could be economically leveraged. That possibility, if it existed, would be an irresistible reason for both corporate and state actors to request time. Whatever its origin, the withholding changed the way knowledge moved. The archive that scientists had trusted, journals, repositories, conferences, acquired many layers of gatekeeping. Published papers sometimes contained appendices noting data upon request with no public path. Press outlets found themselves balancing between embargoed briefings and the public's right to know. In those spaces, rumor thrived. Leaks, partial datasets placed on forums, anonymized mentions at conferences, screenshots of redacted pages became the currency of suspicion. The information ecosystem that had once been primarily about neutral critique had now become an arena where access spelled power. The human cost of that shift is not just epistemic, it is moral. Scientific training inculcates a sense of obligation to truth-telling, to provide evidence sufficient for a claim, to allow peers to verify and challenge. When that obligation becomes negotiable because of non-scientific priorities, it fractures the trust bedrock of collaborative inquiry. Early career researchers, watching gatekeeping in action, must decide whether to play by the rules of patronage or to risk whistleblowing. Whistleblowing has its own career penalties and legal hazards. Recent history provides ample examples of professional ostracism and litigation. Thus, the withholding of data creates incentives for silence that cascade. The system quiets itself not only with formal legal instruments, but through the informal social calculus of risk and reward. Those incentives can have profound effects on the archive itself. When data are withheld, they are not just postponed, they can be altered in their life as record. Processing pipelines that handle proprietary algorithms change raw signals into final interpretations, and those filters shape what is deemed noteworthy. When access to raw files is limited, independent verification becomes impossible. The result is an interpretive monopoly, a small group controlling not only the samples, but the very computational grammar used to translate them into knowledge, yet secrecy does not neatly protect any single truth. The trench's slow kinetics are indifferent to human timelines. Over years and decades, many things leak, not always by design. Samples change hands through legal sale, personnel move between institutions carrying tacit knowledge, old datasets get archived. Inaccessible formats, FOI requests, and court orders reveal parts of sealed records. The long game of information is complex. A withheld dataset may be unusable by the time it surfaces, or it may be picked apart by a broader network of analysts who bring fresh methods and perspectives, sometimes revealing misinterpretations rather than conspiracies. The tortuous path from withholding to revelation is itself part of the trench's lesson about deep time information, like sediment. Moves slowly, pressure reshapes what it contains. The public response to secrecy is a mirror of its own anxieties about the future. Where transparency is absent, narrative fills the void. Conspiracy thrives in the absence of explanation precisely because people crave coherence. The temptation to fill gaps with grand causes, secret agencies preserving knowledge of extraterrestrial artifacts, corporate plans for seabed monopolies, governments hiding evidence of past human industrial activity is powerful. Such narratives are often more emotionally satisfying than careful probabilistic reasoning, and they travel rapidly across social media. The scientific community, which lacks the spectacle of a conspiracy, must navigate this noisy landscape with both restraint and better communication. An honest, open explanation of reasons for temporary restriction, a public articulation of the trade-offs, the expected timeframes, the safeguards would reduce speculation, but that honesty is rarely part of emergent crisis management. The ethical tensions here are substantive. Open science is a moral and practical imperative. Reproducibility, peer critique, and public accountability are pillars of the research enterprise. Yet the claim that certain knowledge might be destabilizing or that its economic exploitation could be consequential is not frivolous. How to reconcile these competing goods, knowledge as public commons and knowledge as strategic resource, is not a technical problem, but a political one. It requires institutions that can credibly adjudicate between competing goods, that can provide independent oversight, that can ensure that emergent value does not translate into private hoarding by default. Without such institutions, the default is a patchwork of secrecy, where the loudest pursuers exercise leverage. The Hadal Project confronted this reality. Faced with anomalies of unclear provenance and potential consequence, the actors involved settled on layered containment. Some material was catalogued and retained by national repositories under classified status. Some data were licensed to private partners under embargo. Some images were released with interpretive framing that emphasized the biological and minimized the ambiguous geochemical signals. That patchwork was defensible. It promised time to verify and to contextualize, but it had the effect of compressing the public discussion into a smaller chamber where power and privilege shape the story. Behind the legal instruments and policy memos, something more human was present, the ache of people torn between two loyalties. Scientists and technicians, described only as an ethos in the public record, felt responsibility both to their discipline's norms and to the constituencies that funded their work. They feared error and fraud equally, and the precautionary impulse that results can be sincere. The institutional habit of pause, verify, then explain has value. Nevertheless, each pause accumulates into wider gaps, and citizens grow suspicious when the rhythm of release yields uneven notes. If secrecy accumulates into silence, the most dangerous silence is not the absence of noise, but the silence that pretends to be protection while functioning as exclusion. That is the silence that transforms a shared archive into a series of vaults with keys held by intersecting authority networks, state, corporation, and private research. The trench itself remains indifferent. It buries and conserves according to physics. Humanity's own strategies for managing its knowledge, however, have consequences for what future researchers will find when they read the layers we leave. The final unavoidable question is one of judgment. If evidence suggests transformative possibilities, whether technological, cultural, or geological, who should decide how and when that knowledge becomes public? The answer is not in a single policy, but in a durable institutional ecology, independent review boards, transparent procedures for temporary embargoes, guarantee pathways for eventual public release, and legal protections for scientists who disclose findings responsibly. Without those scaffolds, the inevitable human temptation to hide will prevail, and knowledge will be parceled in ways that favor the powerful. In the end, the Mariana's political darkness was not less profound than its physical abyss. The trench had taught patience in listening to the planet. It also taught a harder civic lesson, that secrecy can become a second abyss, one split by law, money, and fear. The most terrifying silence, perhaps, is the one that is intentional, the hush constructed to shelter advantage rather than to protect truth. When that silence falls, the archives of the planet risk being read not as neutral records of time, but as curated narratives, edited by human priorities that may outlive the moment but not the judgment of history. And there is a quieter terror still, the idea that important voices have been silenced, not by explicit decree, but by a system of incentives that makes openness costly. The ladder of scientific advancement rests on the assumption that data will circulate. When data stagnates behind closed doors, knowledge becomes brittle. The Hadal, patient and indifferent, will record what humans leave. If humanity leaves in the sediment not only plastics and metal flakes, but also a culture of selective silence, that too will be preserved. In future layers, where isotopes speak and films mineralize, the story of this moment may be read as much in what was withheld as in what was revealed. The depth of the ocean is measured in meters. The depth of a society's responsibility is measured in the span of its silence. The most terrifying silence is the one that chooses to keep secrets from its own descendants. Imagine the Mariana Trench as a library whose volumes are written in mud, microbes, and silence. A place where pages are laminated not with ink, but with layered chemistry and with the slow choreography of life. That never had to explain itself to the sun. That image, once speculative, now stands as the project's final and uneasy metaphor. After years of careful descent, incremental surprise, and a growing stack of anomalous data, the trench can be read in new ways. As an eraser, as an archivist, as a conservatory of ancient practices, and as a theater in which human curiosity and planetary processes stage their uneasy encounter. The last piece of the story is not an extra discovery, but an ethical inflection, a question about whether knowledge should always be pursued at any cost, or whether some doors in Earth's longhouse are better left unlatched. The weight of that question grew from an accumulation of events that had already reconfigured the expectations of deep-time inquiry. The early dives of 2012 and the more systematic probes of 2019 read like a prologue that became increasingly complex. Bioluminescent patrols and gelatinous innovations, microplastics in sediment laminae and isotopic quirks that refused tidy classification, a warm breath of gas that coaxed microbial factories into being, a silent period during which an instrument went mute only to reappear shifted and coated in mucus, and, perhaps most unnerving, a right-angled prominence rising from the mud as if someone had folded a page in a book of earth and left it there. Each event demanded patience. Each demanded methodological humility. Taken together, they also demanded a moral reckoning. There is a pragmatic side to that reckoning. Science, in its best form, is a disciplined curiosity. It is the deliberate lowering of instruments into places that do not expect observers, the careful removal of cores that, once exposed, tell stories never meant for hurried reading. But curiosity is not morally neutral. The act of sampling is an intervention. Lights command attention and can alter behavior. Pumps and thrusters stir a seafloor into unfamiliar eddies. Even the presence of a cable and metal housing becomes a novel substrate for life that will repurpose it. In a place where organisms often respond to the rarest currencies, sheer, dissolved organics, mechanical pressure, human devices become potent stimuli. The trench, which had preserved odd chemistries and possible traces of long persistence, offered one blunt lesson. To know a place is often to change it. That change is not always reversible. Microbial mats that build mineral crusts can be disrupted by a single grab sample. A corridor that sustained generations of soft-bodied swarms might be permanently altered by repeated lighting and mechanical disturbance. Metals introduced, whether as corroded detritus or as the residue of a retrieved tool, can seed new geochemical cycles. The discovery of modern plastics at 11 kilometers depth had astonished the scientific community with its moral bluntness. Human throwaway culture already enters the planet's slow book. But the more subtle consequence is less obvious. Those materials, once integrated, may catalyze new chemical reactions, alter microbial communities, and change the future signatures that would otherwise have been read as markers of long-enduring practices. The trench archives not only what arrives, but how those arrivals are rewritten into the record. There's another axis to the moral calculation: danger. That danger is not the stuff of panic and sensationalism. There are no cinematic monsters waiting beneath the mud. It is a more distributed risk, one that sits at the border between ecology and geopolitics, bringing new energy into the Hadao. By heating, by drilling, by introducing catalytic surfaces, could trigger chemical cascades. Methane-laden pockets, already found in diffuse warm patches, might be mobilized. A local chemical imbalance could become a pulse that releases gas into the water column. Biological communities adapted to an undisturbed regime might be forced into new metabolic states, producing blooms or die-offs with consequences that ripple through broader ocean ecology. Moreover, if the Hadal holds relic biochemistries, enzymatic pathways evolved under conditions that no longer exist on the surface, then exposing those systems to new molecules, new microbes, or new temperatures could create biological exchanges whose long-term outcomes are unknowable. The risk is not immediate catastrophe, but an alteration of the planet's slow page that future scientists and future generations cannot unwrite. These are scientific concerns with an ethical heart. They complicate the simple impulse to answer the most human of questions: what is down there? In many ways, the trench is an irresistible prompt. It sits at once as the planet's deepest silence and as a repository of the Anthropocene's loudest signatures. The sight of a plastic fragment in powdery mud 11 kilometers down is an accusatory image, a trivial object, obscene by location, proving that human presence reaches farther than imagined. But knowing that the deep contains an archive of the Anthropocene does not imply that every archive must be opened now by people eager to claim knowledge or resource. It does suggest that the act of opening is consequential. It will determine what the record becomes. Decision-making has already been shaped by that pressure. Institutional responses reveal the tensions at the heart of contemporary science. Some actors, governments, funding agencies, private contractors, advocate for targeted missions intended to secure and, if desired, exploit knowledge. Exploration can yield new materials, new biotechnologies, new mineral assessments. The economic logic is clear and sometimes compelling. What begins as scientific curiosity can become a foundation for technologies that ameliorate human suffering. The other camp argues for restraint. Their case is not anti-knowledge, but precautionary stewardship. They propose long baseline monitoring, non-invasive in situ assays, and a postponement of intrusive sampling until international frameworks are established to govern the consequences. In practice, those positions are not binary. They shade and entangle. But the tension is real: whose rights to knowledge and to the ocean itself are being recognized, and who decides when and how the trench's pages are to be read. Privacy and secrecy, previously discussed in operational terms, complicate this further. The institutional withholding of data, whether motivated by caution, by economic interest, or by geopolitics, changes the public's ability to participate in the ethical calculus. If anomalies of great consequence are sequestered under proprietary agreements, then the debate about whether to proceed is not a democratic conversation but a negotiation among stakeholders who hold disproportionate power. The result can be perverse: caution cited as reason for secrecy, secrecy then leveraged into privilege. The moral questions about waking the deep are inextricable from the social question about who has the authority to decide. There is, too, a temporal fairness to consider. The trench's slow-cooked archive belongs not only to the present generation but to all future occupants of the planet. A crowded constituency with interests that cannot be represented by immediate economic incentives. Decisions made now will shape what sediments and chemistries persist for millennia. To treat the trench as a commons is to accept that some choices should be delayed until governance structures that reflect global and intergenerational values can be formed. That is an aspiration less popular in the market's short cycles and more comfortable in the long-suffering logics of planetary care. But restraint has costs. It can be used as a shield against scrutiny, and it can postpone knowledge that might be beneficial. The possibility that biochemistries unknown to modern medicine could yield new antibiotics, or that unique catalytic pathways might inform green technologies, is not trivial. There is a moral claim and active pursuit as well: the duty to heal, to innovate, to prevent harm on the scale of climate and material degradation. Scientific discovery has historically alleviated suffering. The same curiosity that demands caution also demands not to be paralyzed by it. The question of awakening the trench is therefore not a question of binary good and evil. It is a balancing act among prudence, curiosity, responsibility, and equity. The choice about whether to intentionally disturb a geological and biological archive must be informed by frameworks that are robust enough to weigh short-term gains against long-term costs and inclusive enough to represent the many constituencies implicated by such a choice: coastal communities that depend on stable fisheries, cultures whose identities tie to the sea, future generations who will inherit a changed planet, and the silent microbial communities themselves that have persisted without human interference for eons. Operationalizing such frameworks will require changes in the governance of ocean science. It means creating transparent mechanisms for sample custody, publicly accessible processing pipelines, independent oversight to adjudicate requests for intrusive sampling, and a default presumption in favor of minimal disturbance unless a compelling, collectively agreed rationale is established. It also means recognizing the unequal distribution of capacity. Wealthy companies and well-funded governments possess access to submersibles, ROVs, and the logistical muscle required for the deepest work. To democratize decisions about the trench's future, partnerships must be structured to amplify underrepresented voices and to ensure that scientific benefits, when realized, are shared equitably. The trench, in that sense, is a test case for what the 21st century must learn about stewardship at planetary scales. It asks whether human societies can temper the drive to know with the humility to refrain, acknowledging that certain discoveries carry costs that extend beyond immediate benefit. It asks whether knowledge is always an unqualified good or whether there are cases where ignorance, exercised intentionally, is a moral stance. There is also a rhetorical and cultural dimension to the choice. Humans are narrators by impulse. The urge to tell the story of the trench has produced captivating images of alien biologies and provocative metaphors of memory and erasure. But narration itself is an act that can smooth over nuance. A different rhetorical practice is needed, one that makes visible the ethical ambiguity, that narrates restraint as an act of care rather than cowardice, and that recognizes patience as a form of cultural maturity. That practice would not stifle wonder, it would complicate it. It would teach that some mysteries are not deficits to be rectified immediately, but responsibilities to be stewarded. In the end, the question returns to the quietest and most intimate of languages, that of choice. Does humanity want to know what lives at the deepest place on the planet, at the risk of changing it irrevocably? Or is there value in deferring curiosity, in leaving the trench a sleeping archive, so that future stewards, better governed, more equitable, perhaps wiser, might open it with a different set of priorities? The answer is not merely empirical, it is ethical and political, a reflection of what present societies value and of what legacy they wish to leave. The Mariana Trench does not demand an answer now. It offers, instead, a charge to imagine governance that stretches beyond electoral cycles and quarterly profits, to embed precaution into the design of instruments and into the norms of publication, to require that the scientific imperative be exercised with an equal measure of frugality and imagination. The trench itself is patient. It has survived tectonic fury, mass extinctions, and glacial revolutions. Its patience is a rebuke to the human cadence of immediate return. In that patience, it also bequeaths the possibility that restraint can be a gift. When researchers stand, collectively, anonymously, at the lip of that abyss, the feeling is not simply hunger for knowledge. It is a mingling reverence for an archive that rewrites our assumptions about persistence, guilt about the Anthropocene, signatures we have already sown into the mud, wonder at biological novelty, and a quiet terror at the potential consequences of our interventions. The final question that Mariana leaves on the table is therefore less about capability and more about choice. The capacity to know is enormous and growing. Whether that capacity should be exercised and on what terms is the more consequential query. Do we really want to know what lives beneath 11 kilometers of water, to drag the vault open, to let our light scatter and our samplers tend the wound, or is there virtue in allowing the planet to keep some of its deepest? Pages closed. The trench keeps its own counsel, indifferent and patient. The choice now sits with the species that, in the space of a few centuries, has learned to reach even the quietest rooms of Earth's house. That choice will be a measure of collective wisdom, whether modernity can learn the ancient discipline of restraint, and whether humanity can honor a form of knowing that includes the courage to leave some things undisturbed. The question is left, not as a puzzle to be solved in a single moment, but as a slow imperative, to listen longer, to govern better, and to decide whether waking what sleeps at the bottom of the world is an act of illumination or an erasure.